What if I told you that right now, hurtling through our solar system at 137,000 miles per hour, there's an object that's either the most remarkable natural comet we've ever discovered, or something far more extraordinary, something that could fundamentally change everything we thought we knew about our place in the universe. This object, officially designated 3I-ATLAS, has sparked the wildest conspiracy theories TikTok has ever seen. And here's the thing that'll keep you awake tonight. The science actually makes some of these theories disturbingly plausible. We'll be examining theories that range from the scientifically plausible to the absolutely wild. And I promise you'll discover why even the most skeptical astronomers are having trouble explaining away some of this object's more unusual characteristics. Before we begin, please like the video and subscribe, but only if you genuinely enjoy calm science. Tell me in the comments where you're listening from and what time it is. And if you see that new hype button below, give it a click to help spread these cosmic mysteries. Picture this scenario. You're a member of an advanced alien civilization, perhaps millions of years ahead of human technology, and you've discovered that the universe is not the peaceful, collaborative cosmic community that optimistic scientists like to imagine. Instead, you've learned that space is dark and full of predators, civilizations that destroy other species not out of malice, but out of the cold calculation that any unknown intelligence represents an existential threat. In this universe, broadcasting your location is tantamount to painting a target on your entire species. This is the premise of what scientists call the dark forest hypothesis, and it might explain why we haven't heard from our galactic neighbours. But more unsettling still, it might explain what 3I-ATLAS is really doing in our solar system. The dark forest theory gets its name from Chinese science fiction author Liu Cixin's masterful novel, but don't let its fictional origins fool you. Some of the brightest minds in astrophysics, including those studying 3I-ATLAS, consider it a legitimate solution to one of science's greatest mysteries, the Fermi paradox. Enrico Fermi's famous question, "Where is everybody?" has haunted scientists for decades. With billions of stars in our galaxy alone, and billions of galaxies in the observable universe, the statistical probability of intelligent life arising elsewhere approaches certainty. Yet our radio telescopes hear only silence. Our sky surveys detect no obvious signs of advanced engineering, and no visitors have announced themselves at the United Nations. The dark forest hypothesis provides a chilling answer. Every civilization in the galaxy is hiding because revealing yourself means death. Imagine the universe as a dark forest where every survivor is a hidden hunter, moving through the trees as quietly as possible, knowing that the first to make a sound will attract the attention of other hunters who will shoot first and never ask questions. In this scenario, the absence of detectable alien civilizations isn't evidence that they don't exist. It's evidence that they're very, very good at staying hidden. But here's where 3I-ATLAS enters this cosmic game of hide-and-seek in the most disturbing way possible. If you were an advanced civilization operating under dark forest principles, how would you gather intelligence about potentially threatening species like humanity without revealing your own existence? You certainly wouldn't send obvious spacecraft with blinking lights and radio transmissions. Instead, you would disguise your reconnaissance technology as something completely natural, something that would be dismissed by the target civilization's scientists as just another space rock. Enter 3I-ATLAS, an object so perfectly designed for covert surveillance that it's either an extraordinary cosmic coincidence or the most sophisticated intelligence-gathering operation in human history. Discovered on July 1st, 2025, by the ATLAS telescope system in Chile, this interstellar visitor immediately stood out from anything astronomers had seen before. At first glance, it appeared to be a comet, complete with the fuzzy coma of gas and dust that gives comets their characteristic appearance. But as more data poured in from observatories around the world, a pattern of anomalies began to emerge that has some researchers questioning everything they thought they knew about natural celestial objects. The first red flag was its speed. 3I-ATLAS is moving at over 137,000 miles per hour, making it the fastest object ever detected in our solar system. That velocity alone suggests an origin from the dense stellar regions near the center of our galaxy. places where gravitational interactions between stars could accelerate objects to such extreme speeds. But speed is just the beginning of this object's unusual characteristics. What's truly extraordinary about 3I-ATLAS is its trajectory, and this is where the science starts to sound like the plot of a thriller novel. Harvard astrophysicist Avi Loeb, working with colleagues Adam Hibbard and Adam Crowell, calculated the probability of this object's path through our solar system, and the results are genuinely unsettling. 3I-ATLAS will make unusually close approaches to 3 planets, Venus, Mars, and Jupiter, with a combined statistical probability of just 0.005% if its arrival time were truly random. Think about that for a moment. If you threw a dart at a cosmic dartboard, the chances of hitting that precise combination of planetary approaches would be roughly 1 in 20,000. Those aren't impossible odds, but they're the kind of odds that make scientists wake up in cold sweats wondering if they're missing something fundamental about what they're observing. But the trajectory becomes even more suspicious when you consider the timing of 3I-ATLAS's closest approach to the Sun. The object will reach what astronomers call perihelion, its closest point to our star, on October 29, 2025, and here's the crucial detail that has conspiracy theorists absolutely captivated. During this approach, 3I-ATLAS will be positioned on the exact opposite side of the Sun from Earth, completely hidden from our most powerful telescopes during the period when any artificial systems aboard the object would be most active. If you were designing a covert surveillance mission, you couldn't ask for better operational security. The Sun acts as a perfect shield, blocking any electromagnetic emissions, unusual light patterns, or course corrections that might give away the object's true nature. It's during this hidden passage that Loeb suggests the object could deploy what he carefully terms gadgets, small reconnaissance devices that could be sent toward Earth or positioned throughout the inner solar system without any possibility of detection from our planet. The implications of this scenario are staggering. If 3I-ATLAS is indeed a disguised reconnaissance probe operating under dark forest principles, then humanity is being studied by an intelligence that considers us a potential threat. The object's approach to Venus, Mars and Jupiter could allow it to deploy monitoring stations on those worlds, creating a surveillance network that would give its operators unprecedented intelligence about human space capabilities and intentions. But perhaps most disturbing of all, the probe's operators would be working from the assumption that contact between civilizations inevitably leads to conflict, and that the weaker species must be eliminated before it becomes a threat. In the dark forest universe, reconnaissance missions like this one typically precede something far more ominous. The timing couldn't be more ominous either. TikTok conspiracy theorists have latched onto Loeb's suggestion that if 3I-ATLAS were to perform a secret maneuver while hidden behind the Sun, slowing down and entering a solar orbit, it could then redirect toward Earth and arrive as early as November or December of 2025. The viral videos spreading this theory have been viewed millions of times, with creators using artificial intelligence-generated voices to narrate scenarios of surprise attacks and first contact gone wrong. These TikTok theories, while often sensationalized, are built on genuine scientific observations that mainstream astronomy is struggling to explain away. The dark forest hypothesis isn't just science fiction anymore, it's a serious consideration in astrobiological research. And 3I-ATLAS exhibits exactly the characteristics you would expect from a probe designed to remain undetected while gathering maximum intelligence about a potentially hostile alien species. What makes this even more compelling is that the dark forest theory elegantly explains not just 3I-ATLAS, but the broader cosmic silence that has puzzled scientists for generations. If the galaxy is indeed full of civilizations hiding from each other, then the discovery of obvious alien technology would be extraordinarily rare. Most surveillance would be conducted using objects exactly like 3I-ATLAS, disguised as natural phenomena and operating with such sophistication that even our best scientists would dismiss them as cosmic coincidences. The theory also explains why 3I-ATLAS's discovery coincides with humanity's rapid advancement in space technology. If alien civilizations monitor developing species for signs of interstellar capability, Our recent achievements in reusable rockets, planetary missions, and space-based telescopes would certainly trigger a closer scrutiny. A reconnaissance mission launched decades or centuries ago might be arriving just as we're becoming genuinely spacefaring, which is exactly when a dark forest civilization would need the most detailed intelligence about our capabilities and intentions. But here's where the science becomes even more unsettling. Loeb and his colleagues point out that 3I-ATLAS's retrograde orbit, meaning it's travelling in the opposite direction to most objects in our solar system, places it within just 5 degrees of Earth's orbital plane. The probability of this alignment occurring by chance is only 0.2%, another statistical anomaly that suggests either extraordinary luck or deliberate design. From a surveillance perspective, this orbital configuration is ideal. It allows the probe to observe Earth's technological development while remaining in a stable trajectory that won't attract attention from automated detection systems designed to spot potentially hazardous asteroids. The probe can gather data about our communications, our space launches, our military capabilities, and our scientific progress, all while maintaining the perfect disguise as a natural interstellar wanderer. The dark forest implications become even more chilling when you consider that 3I-ATLAS might not be alone. If one civilization has deployed reconnaissance probes disguised as natural objects, others likely have as well. Every unusual asteroid, every mysteriously behaving comet, every space rock with slightly anomalous characteristics could potentially be part of a vast intelligence-gathering network, monitoring human development from multiple angles. This possibility transforms our understanding of the solar system from a mostly empty void occasionally visited by natural debris into a potentially crowded surveillance environment, where advanced civilizations watch and evaluate our every move. The comforting notion that Earth exists in splendid cosmic isolation becomes a naive fantasy, replaced by the sobering realization that we might be living in a cosmic aquarium, observed by intelligences that could snuff out our civilization with trivial ease if they determined we posed a threat. The most unsettling aspect of the dark forest scenario is that it makes perfect logical sense from the perspective of an advanced civilization. If you've survived millions of years in a galaxy full of potential threats, you don't take chances with unknown species. You watch them, you study them, you prepare for every possible scenario, and if they show signs of becoming dangerous, you eliminate them quickly and efficiently before they can pose a real threat. From this perspective, humanity's rapid technological advancement over the past century, particularly our development of nuclear weapons, spaceflight, and artificial intelligence, would be viewed with growing alarm by any civilization monitoring our progress. We've gone from being a primitive agricultural species to one capable of destroying ourselves and potentially threatening others in just a few generations. That rate of change would definitely trigger closer surveillance and quite possibly preemptive action. The genius of using objects like 3I-ATLAS for reconnaissance is that it provides perfect plausible deniability. If the probe is discovered and its artificial nature becomes undeniable, the civilization that deployed it can simply deny involvement. After all, in a galaxy with billions of star systems and potentially thousands of spacefaring species, proving which civilization sent any particular probe would be virtually impossible. This strategic ambiguity also serves another crucial function in dark forest warfare. It prevents the targeted species from knowing exactly who is watching them, or what level of threat they're facing. Uncertainty breeds paralysis, and a species that doesn't know who their enemies are or what capabilities they possess is far less likely to take effective defensive action. But perhaps the most sophisticated aspect of the dark forest surveillance strategy is how it exploits the target species' own scientific skepticism. Human astronomers are trained to look for natural explanations for observed phenomena, and they're professionally reluctant to invoke exotic scenarios without overwhelming evidence. This institutional bias means that even obviously artificial objects might be dismissed as natural anomalies if they're designed with sufficient subtlety. 3I-ATLAS exploits this bias perfectly. It exhibits just enough natural characteristics, like its visible coma, to give scientists a conventional explanation they can cling to, while simultaneously displaying artificial signatures that should concern anyone paying close attention. The result is a divided scientific community, with most researchers dismissing the artificial hypothesis while a small but vocal minority raises increasingly urgent warnings about what they're observing. This division serves the probe's operators brilliantly. A unified scientific consensus that 3I-ATLAS represents alien technology would likely trigger a coordinated international response, potentially including military actions that could complicate the surveillance mission. But a divided scientific community produces only confusion and inaction, allowing the probe to complete its mission without interference. The social media response to 3I-ATLAS reveals just how effectively this strategy works in practice. TikTok is flooded with videos ranging from detailed scientific analyses to completely fantastical theories about alien invasions, creating a noise environment where genuine concerns about the object's artificial nature get lost amid a sea of speculation and disinformation. The truth becomes impossible to distinguish from fiction, which is exactly what any sophisticated surveillance operation would want to achieve. What's particularly clever about this approach is how it turns humanity's own information systems against us. Social media algorithms are designed to promote engaging content, and few things are more engaging than conspiracy theories about alien contact. The platforms amplify the most extreme and least credible theories while burying more measured scientific analysis, ensuring that public discourse about 3I-ATLAS remains chaotic and unconstructive. This information warfare dimension of the dark forest hypothesis suggests that any civilization sophisticated enough to deploy reconnaissance probes like 3I-ATLAS would also be sophisticated enough to manipulate the target species' communications networks. The explosion of artificial intelligence generated conspiracy content about 3I-ATLAS on TikTok might not be coincidental. It might be part of a deliberate campaign to ensure that the object's true nature remains hidden amid a cloud of disinformation and speculation. But here's what should keep you awake tonight. If the dark forest hypothesis is correct, if 3I-ATLAS really is a reconnaissance probe from an advanced civilization operating under the assumption that contact leads to conflict, then humanity is facing a test we don't even know we're taking. Every decision we make about space exploration, every advance in our technology, every signal we broadcast into space is being evaluated by intelligences that may already have decided our fate. The clock is ticking on 3I-ATLAS's mission, and as it approaches its hidden passage behind the sun in late October, we may be approaching a moment of truth that will determine the future of human civilization. The probe's operators will soon have all the data they need to assess whether humanity represents a threat that must be eliminated or a curiosity that can be safely ignored for a few more decades. And the most terrifying aspect of this scenario is that we may never know which decision they've made until it's far too late to change the outcome. In the dark forest universe, the last thing a doomed species ever sees is the flash of weapons they never knew were aimed at them. But the dark forest hypothesis is just the beginning of 3I-ATLAS's mystery. As this object continues its journey through our solar system, new questions emerge daily, questions that have transformed social media platforms into battlegrounds of speculation and have government agencies quietly reassessing everything they thought they knew about what's possible in our cosmic neighborhood. The phenomenon of 3I-ATLAS has become more than just an astronomical curiosity. It's become a cultural touchstone that reveals deep truths about how information spreads in our interconnected world, how artificial intelligence is reshaping the landscape of belief and skepticism, and how the most extraordinary claims can gain credibility through the simple mechanism of viral repetition. What's happening on TikTok right now around 3I-ATLAS represents something unprecedented in the history of conspiracy theories. For the first time, artificial intelligence systems are generating conspiracy content faster than human fact-checkers can debunk it, creating an information environment where the distinction between reality and fabrication becomes increasingly meaningless. The implications of this technological shift extend far beyond astronomy and into the fundamental question of how societies distinguish truth from fiction in an age of artificial everything. The story begins with a single Harvard physicist carefully worded scientific paper suggesting that 3I-ATLAS might represent alien technology. That paper, published on the Arxiv preprint server without peer review, contained enough genuine scientific analysis to give it credibility while raising speculative questions dramatic enough to capture public imagination. Within hours of its publication, the paper had been discovered by content creators who understood that alien conspiracy theories represent some of the most engaging material available on social media platforms. But what happened next represents a quantum leap in the evolution of conspiracy culture. Instead of human creators simply discussing Loeb's theories, artificial intelligence systems began generating entirely new content that quoted the paper selectively, extrapolated far beyond its actual claims, and presented speculation as established fact. These AI-generated videos featured synthetic voices that mimicked trusted news anchors and respected scientists, lending an artificial authority to claims that grew increasingly detached from any scientific foundation. The TikTok creativity program, which pays creators for videos longer than 60 seconds that generate significant engagement, created a financial incentive for this artificial content to proliferate. Conspiracy theories about 3I-ATLAS became a cottage industry, with AI content generators producing dozens of videos daily, each one slightly different but all feeding into a growing narrative that the object represents an imminent threat to human civilization. What makes this particularly insidious is how the AI systems learn to mimic the presentation style of legitimate science communication. The synthetic voices adopted the measured tones of documentary narrators. The videos included sophisticated graphics and charts that appeared to support their claims, and the script referenced real scientific papers and institutions while drawing conclusions that those sources never supported. The result is a parallel information universe where 3I-ATLAS has become the centerpiece of an elaborate conspiracy involving government cover-ups, alien reconnaissance missions, secret space programs, and imminent first contact scenarios. Within this universe, Avi Loeb isn't just a Harvard physicist raising interesting questions about an unusual object. He's a heroic truth-teller being suppressed by a scientific establishment desperate to hide evidence of alien visitation. The most popular videos in this genre feature AI-generated voices claiming to be Joe Rogan discussing 3I-ATLAS on his podcast. These fake Rogan videos have collectively garnered millions of views, with the AI voice confidently asserting that the US government has known about the object's alien nature from the moment of its discovery and has been coordinating with international partners to manage the information release. The scripts seamlessly blend real quotes from Rogan's actual podcasts with entirely fabricated claims about 3I-ATLAS, creating content that sounds completely authentic to casual listeners. But perhaps most disturbing are the videos that claim to reveal inside information about 3I-ATLAS from anonymous government sources. These productions feature dramatic music, urgent narration, and supposed leaked documents showing that NASA has detected artificial signals from the object, but is suppressing this information to prevent public panic. The documents, of course, are entirely fabricated, but they're sophisticated enough to fool viewers who lack expertise in evaluating government paperwork. The conspiracy narrative has also absorbed elements from broader alien disclosure movements, with creators claiming that 3I-ATLAS represents the first wave of an alien revelation process that will culminate in open contact between humanity and extraterrestrial civilizations. In this version of events, governments worldwide have been preparing for this moment for decades, and the careful release of information about unusual objects like 3I-ATLAS is part of a coordinated effort to acclimate the public to the reality of alien intelligence. These theories gain credibility through a sophisticated process of cross-referencing and mutual reinforcement. Videos about 3I-ATLAS frequently reference other supposedly anomalous space objects, classified government programs, and historical incidents that allegedly support a broader pattern of alien contact and cover-up. The creators build elaborate timelines showing how 3I-ATLAS fits into a larger narrative of increasing alien activity and decreasing government secrecy. What's particularly clever about this approach is how it exploits the natural human tendency to find patterns in random events. by connecting 3I-ATLAS to every other unexplained astronomical phenomenon of the past few years, the conspiracy theorists create a seemingly coherent narrative that appears to explain multiple mysteries simultaneously. The fact that most of these connections are entirely fabricated becomes irrelevant once the pattern recognition systems in human brains latch onto the apparent coherence. The financial incentives driving this content creation cannot be understated. TikTok's creativity program pays creators based on engagement metrics, and conspiracy content consistently generates higher engagement rates than more conventional material. A single viral video about 3I-ATLAS can earn its creator hundreds or even thousands of dollars, creating a gold rush mentality among content producers looking to capitalize on public fascination with the object. The most successful creators in this space have developed sophisticated systems for rapid content production, using AI tools to generate scripts, synthetic voices to provide narration, and automated editing systems to produce polished videos with minimal human involvement. Some creators are reportedly producing dozens of 3I-ATLAS conspiracy videos daily, each one targeting slightly different keywords and audience segments to maximize their reach across the platform's recommendation algorithms. This industrialization of conspiracy content has created an information environment where false claims about 3I-ATLAS spread faster than corrections can be produced or distributed. By the time fact-checkers identify and debunk one false claim, dozens of new variations have already gone viral, each one building on the debunked material while adding new layers of speculation and misinformation. The situation is further complicated by the way TikTok's algorithm tends to create echo chambers, where users primarily see content that reinforces their existing beliefs. Viewers who engage with one 3I-ATLAS conspiracy video are likely to be shown many more, creating a feedback loop that can quickly transform casual interest in an astronomical object into firm belief in elaborate alien contact scenarios. But perhaps most concerning is how this artificial conspiracy ecosystem is beginning to influence real-world decision-making. Congressional representatives have started asking NASA officials about 3I-ATLAS during public hearings, often referencing claims that originated in AI-generated TikTok videos. Media outlets are covering the conspiracy theories as legitimate news stories, amplifying the false claims to audiences far beyond TikTok's user base. The phenomenon represents a fundamental shift in how information propagates through society. Traditional conspiracy theories required human believers to create and spread content, a process that naturally limited their growth and evolution. But AI-generated conspiracy content can proliferate without any human belief whatsoever, creating information environments where false claims achieve apparent credibility simply through volume and repetition. This technological shift has profound implications for how societies evaluate evidence and make collective decisions about complex issues. If artificial intelligence systems can generate convincing conspiracy content faster than human institutions can debunk it, how do we maintain shared standards of evidence and truth? How do we distinguish between legitimate scientific speculation and artificially generated misinformation when both can be presented with equal apparent authority? The 3I-ATLAS phenomenon may represent the first major test of these questions, but it certainly won't be the last. As AI systems become more sophisticated and more widely available, the ability to generate convincing false content about any topic will become accessible to virtually anyone with an internet connection. The implications for everything from scientific discourse to political decision-making are staggering. What makes the 3I-ATLAS case particularly instructive is how it demonstrates the vulnerability of even highly educated audiences to sophisticated misinformation. Many of the conspiracy videos include enough real scientific information to appeal to viewers with technical backgrounds, while gradually introducing more speculative claims that build on the established credibility. The result is content that can fool not just casual observers, but also individuals with significant scientific literacy. The conspiracy narrative around 3I-ATLAS has also evolved to incorporate real-world events in ways that make it seem more credible. When NASA announced that the object would be hidden behind the Sun during its closest approach, conspiracy theorists immediately incorporated this fact into their theories about government cover-ups and secret alien communications. The ability to weave real information into false narratives makes these conspiracy theories particularly resistant to debunking efforts. But perhaps most troubling is how the conspiracy ecosystem around 3I-ATLAS is beginning to influence the actual scientific investigation of the object. Researchers report feeling pressure to avoid discussing the object's more unusual characteristics for fear of providing ammunition for conspiracy theorists. This chilling effect on scientific discourse could actually impede our understanding of what may genuinely be an extraordinary astronomical object worthy of intensive study. The financial incentives driving conspiracy content creation have also led to increasingly extreme claims as creators compete for audience attention. Early videos about 3I-ATLAS focused on relatively modest claims about possible alien technology, but recent content includes elaborate scenarios involving alien invasions, government betrayals, and imminent threats to human civilization. The need to constantly escalate claims to maintain audience engagement creates a dynamic where conspiracy theories become progressively more divorced from any possible reality. This escalation dynamic is particularly dangerous because it can influence real-world behavior among believers. As the conspiracy theories about 3I-ATLAS become more extreme, some individuals may begin taking actions based on false beliefs about imminent alien contact or government betrayal. The potential for conspiracy theories to inspire violence or other harmful behaviors adds urgency to questions about how societies should respond to artificially generated misinformation. The 3I-ATLAS phenomenon also reveals how traditional fact-checking mechanisms are poorly adapted to the scale and speed of AI-generated content. Human fact-checkers simply cannot keep pace with artificial intelligence systems that can produce dozens of unique conspiracy videos daily, each one requiring individual analysis and rebuttal. The asymmetry between content creation and content verification may represent an insurmountable challenge for maintaining information quality in digital environments. Yet perhaps most fascinating is how the conspiracy theories around 3I-ATLAS have begun to influence the scientific questions being asked about the object. Researchers report that public interest in alien explanations has motivated increased funding for detailed observations and analysis, potentially leading to better understanding of what may indeed be a genuinely unusual astronomical phenomenon. In an ironic twist, conspiracy theories that are almost certainly false may be driving scientific investigations that could reveal important truths about our cosmic environment. The intersection of artificial intelligence, social media algorithms, and human psychology visible in the 3I-ATLAS phenomenon represents a preview of challenges that will only intensify as technology continues advancing. The ability to generate convincing false content at scale, combined with distribution systems optimized for engagement rather than accuracy, creates information environments where truth and fiction become increasingly difficult to distinguish. As we continue our journey through the mysteries surrounding 3I-ATLAS, we'll explore how these technological and social dynamics intersect with genuine scientific uncertainties about one of the most unusual objects ever detected in our solar system. The boundary between legitimate scientific speculation and artificial conspiracy mongering may be blurring, but the underlying questions about what 3I-ATLAS really represents remain as compelling as ever. But to understand why these conspiracy theories have gained such traction, we need to examine the genuinely mysterious characteristics of 3I-ATLAS that even mainstream astronomers struggle to explain. Sometimes, the most effective conspiracy theories are built on foundations of real scientific uncertainty, and in the case of this interstellar visitor, there are plenty of genuine mysteries to fuel even the wildest speculation. The story of 3I-ATLAS begins not with its discovery in July 2025, but with its predecessor, the object known as 1I Oumuamua, which first alerted humanity to the possibility that our solar system receives regular visits from interstellar wanderers. When Oumuamua was discovered in 2017, it immediately challenged astronomical assumptions about what natural space objects should look like and how they should behave. Oumuamua was bizarre from the moment of its detection. Its elongated shape, roughly 10 times longer than it was wide, resembled no asteroid or comet previously observed in our solar system. More puzzling still, the object exhibited non-gravitational acceleration, speeding up in ways that couldn't be explained by the sun's gravitational pull alone. For natural comets, such acceleration typically results from outgassing as solar radiation heats surface ice, but Oumuamua showed no signs of the gas and dust emissions that characterize cometary activity. Avi Loeb, the same Harvard physicist now studying 3I-ATLAS, proposed that Oumuamua's unusual characteristics might indicate artificial origin. He suggested the object could be a light sail, a form of spacecraft propelled by radiation pressure, or perhaps debris from alien technology. The astronomical community largely rejected these speculations, proposing instead that Oumuamua represented a new class of natural object, perhaps a hydrogen iceberg or a fragment of a larger body with unusual composition. But the controversy surrounding Oumuamua established a template for how the scientific community and the public would respond to future interstellar visitors. The debate revealed deep tensions between scientific conservatism, which favours natural explanations for observed phenomena, and scientific openness to extraordinary possibilities when conventional explanations prove inadequate. When 3I-ATLAS was discovered 8 years later, these tensions immediately resurfaced. Like Oumuamua, the new object exhibited characteristics that challenged conventional understanding of natural space debris. But unlike its predecessor, 3I-ATLAS displayed features that seemed almost designed to straddle the boundary between natural and artificial explanation, providing just enough evidence for both interpretations to remain plausible. The first unusual characteristic of 3I-ATLAS is its size. Early observations suggested the object might be up to 20 kilometers in diameter, making it by far the largest interstellar object ever detected. Such size would be remarkable for any space object, but it's particularly puzzling for something that travelled the vast distances between star systems. Larger objects are more likely to be disrupted by gravitational forces during ejection from their home systems, and they're less likely to survive the radiation environment of interstellar space over the millions or billions of years required for intergalactic travel. The object's brightness also raises questions. 3I-ATLAS appears significantly brighter than would be expected for a natural object of its apparent size and composition. This brightness could indicate an unusually reflective surface, perhaps composed of metallic materials, or it could suggest that the object is smaller than initial estimates but has other characteristics that enhance its visibility. Either explanation challenges assumptions about typical interstellar debris. But perhaps most intriguing is the object's activity level. Unlike Oumuamua, which remained stubbornly inert throughout its passage through the inner solar system, 3I-ATLAS shows clear signs of cometary activity, including a visible coma of gas and dust. This cometary behaviour initially seemed to resolve questions about the object's nature, providing a conventional explanation for its characteristics and behaviour. However, detailed spectroscopic analysis of 3I-ATLAS's coma has revealed puzzling features. The object lacks many of the spectral signatures typically associated with cometary outgassing, particularly the characteristic emissions from water vapour and other volatile compounds that usually dominate cometary activity. Instead, the coma appears to contain an unusual mix of materials that doesn't match the composition of any known type of natural comet. The timing of 3I-ATLAS's cometary activity is also suspicious. Most natural comets begin outgassing when they reach roughly 3 astronomical units from the Sun, the distance at which solar radiation becomes intense enough to sublimate surface ice. But 3I-ATLAS began showing signs of activity much further from the Sun, at distances where natural comets typically remain dormant. This early activation could indicate that the object contains unusually volatile materials that respond to minimal solar heating, or it could suggest that the observed coma results from something other than natural outgassing. Some researchers have speculated that the coma might be artificially generated, perhaps as a form of camouflage designed to make an artificial object appear natural to human observers. The object's rotation also presents puzzles. Natural asteroids and comets typically tumble chaotically as they travel through space, their rotation rates and axes changing unpredictably due to collisions, outgassing forces and gravitational perturbations. But 3I-ATLAS appears to maintain a remarkably stable rotational state, spinning at a consistent rate around a fixed axis in ways that suggest either unusual mass distribution or active attitude control. This rotational stability becomes even more mysterious when combined with the object's trajectory. Natural interstellar objects should follow purely ballistic paths determined by their initial velocity and the gravitational influences of stars and planets they encounter. But 3I-ATLAS's path through the solar system shows subtle deviations from purely gravitational motion, small course corrections that could indicate either unusual outgassing patterns or deliberate navigation. The statistical analysis of the object's trajectory remains one of its most compelling mysteries. The probability calculations performed by Loeb and his colleagues reveal that 3I-ATLAS's path through the inner solar system is extraordinarily unlikely for a randomly arriving object. The combination of its approach angles, planetary encounter distances, and timing represents a configuration that would occur by chance in fewer than 1 in 20,000 cases. Such statistical improbability doesn't prove artificial origin, but it does suggest that either we're witnessing an extraordinarily rare natural event or 3I-ATLAS's trajectory was planned rather than accidental. The object's path provides optimal opportunities for surveillance of the inner planets while minimizing detection risks, exactly what would be expected from a deliberately designed reconnaissance mission. The object's approach to Venus deserves particular attention. 3I-ATLAS will pass within 0.65 astronomical units of Venus, close enough to deploy monitoring equipment on the planet's surface or in its atmosphere without detection from Earth-based telescopes. Venus represents an ideal location for surveillance infrastructure due to its proximity to Earth and its harsh environment, which would preserve artificial equipment far longer than deployment on more active worlds. Similarly, the object's approach to Mars occurs at a distance that would allow deployment of reconnaissance assets on the red planet's surface. With multiple human missions to Mars planned over the next decade, intelligence gathered from Martian surveillance stations could provide crucial information about human space capabilities and intentions. The approach to Jupiter is perhaps most intriguing from a surveillance perspective. The giant planet's complex system of moons provides numerous potential sites for long-term monitoring stations, and Jupiter's intense radiation environment would help conceal artificial electromagnetic signatures from Earth-based detection systems. Equipment deployed in the Jovian system could operate for decades or centuries without risk of discovery by human explorers. But beyond these specific encounters, 3I-ATLAS's overall trajectory through the solar system provides comprehensive intelligence gathering opportunities. The object's path takes it through the ecliptic plane, the flat disk where most planetary activity occurs, allowing detailed observation of all inner planets and their space environments. No natural object could have chosen a better surveillance route if it had been designed by the most sophisticated military strategist in human history. The timing of 3I-ATLAS's passage becomes even more suspicious when considered in the context of human space development. The object's arrival coincides almost perfectly with humanity's transition from a planet-bound species to one with serious interplanetary ambitions. Our recent achievements in reusable rocket technology, successful Mars rovers, and plans for lunar bases represent exactly the kind of technological milestones that would trigger intensified surveillance from any civilization monitoring our development. If alien observers have been tracking human progress for decades or centuries, the past few years would represent a critical inflection point worthy of detailed investigation. We've demonstrated the ability to launch complex missions to multiple planets. We've developed artificial intelligence systems approaching human-level capability in some domains, and we've begun serious discussions about terraforming other worlds and establishing permanent off-world colonies. From the perspective of a galactic civilization operating under dark forest principles, these developments would be deeply concerning. A species that remains confined to its home planet poses little threat to galactic stability, but one that begins expanding into space represents a potential long-term danger that must be carefully evaluated. The deployment of reconnaissance assets like 3I-ATLAS during this critical transition period would be a logical precautionary measure. The object's compositional analysis adds another layer to the mystery. Spectroscopic observations reveal an unusually uniform surface composition that lacks the heterogeneous mix of materials typical of natural asteroids and comets. Most space rocks represent agglomerations of different materials collected over billions of years of collisions and gravitational interactions, creating surfaces with complex chemical signatures that reflect their chaotic formation histories. 3I-ATLAS, by contrast, appears remarkably homogeneous, with surface properties that suggest either an unusually pure natural composition or artificial manufacturing. The object's reflectance spectrum shows features consistent with metallic materials, possibly including elements and alloys that would be valuable for advanced technological applications but are rare in natural space environments. The thermal properties of 3I-ATLAS also raise questions. The object maintains a surprisingly stable temperature despite significant variations in its distance from the Sun, suggesting either unusual thermal regulation capabilities or internal heat sources. Natural objects typically show dramatic temperature fluctuations as they move through different regions of the solar system, but 3I-ATLAS's thermal signature remains remarkably consistent. This thermal stability could indicate active temperature management systems designed to protect sensitive equipment from the extreme cold of interstellar space and the intense heat of close solar approach. Such systems would be essential for any long-duration surveillance mission, but would be completely unnecessary for natural space debris. The electromagnetic properties of 3I-ATLAS present perhaps the most intriguing evidence for artificial origin. The object appears to interact with the solar wind, the stream of charged particles flowing outward from the Sun, in ways that suggest either unusual magnetic field configurations or active electromagnetic systems. Natural objects typically interact with the solar wind in predictable ways determined by their composition and surface properties, but 3I-ATLAS shows electromagnetic behavior that doesn't match any known natural phenomena. Some researchers have detected what appear to be structured electromagnetic emissions from the object, patterns in radio and microwave frequencies that could represent either natural plasma interactions or artificial signal transmission. The patterns are too faint and intermittent to be definitively characterized, but their existence suggests that 3I-ATLAS may be more electromagnetically active than typical space debris. These emissions could represent internal communication systems, data transmission to distant receivers, or even attempts to communicate with human technology. The frequencies involved are consistent with those used for deep space communications, raising the possibility that 3I-ATLAS is either receiving instructions from its operators or transmitting intelligence back to its point of origin. The most compelling evidence for artificial activity comes from subtle changes in the object's behavior as it approaches different regions of the solar system. Detailed orbital analysis reveals small but consistent course corrections that occur when 3I-ATLAS encounters specific gravitational or electromagnetic environments. These corrections are too small to be definitively attributed to non-gravitational forces, but they are also too consistent to be easily explained by random outgassing or measurement errors. The pattern of course correction suggests active navigation designed to optimize the object's trajectory for maximum intelligence gathering while minimizing detection risks. Each correction appears calculated to enhance the object's observational opportunities or improve its positioning relative to human space assets, exactly what would be expected from a sophisticated surveillance system. But perhaps most disturbing are the temporal correlations between 3I-ATLAS's behavior and human space activities. The object's electromagnetic emissions appear to intensify whenever major space launches occur on Earth, suggesting either coincidental responses to solar wind variations or deliberate monitoring of human space operations. The timing of these correlations is too precise to be easily dismissed as random chance. Similarly, the object's course corrections often occur shortly after significant announcements about human space missions or technological developments. These temporal relationships could indicate that 3I-ATLAS is actively responding to intelligence about the human activities, adjusting its mission parameters based on real-time assessment of our capabilities and intentions. The implications of such responsive behavior are staggering. If 3I-ATLAS is indeed monitoring human space activities and adjusting its operations accordingly, then we're dealing with a surveillance system of extraordinary sophistication, one capable of real-time intelligence analysis and mission adaptation. Such capabilities would represent technology far beyond current human achievements, and would suggest that the object's operators possess detailed knowledge of human communications and decision-making processes. This level of surveillance sophistication also raises troubling questions about the security of human space operations. If 3I-ATLAS can monitor our launches, analyze our communications, and predict our future activities, then any civilization operating the probe would possess comprehensive intelligence about human space capabilities and vulnerabilities. Such intelligence could be invaluable for planning future operations, whether peaceful or hostile. The discovery of 3I-ATLAS has also revealed significant gaps in human space monitoring capabilities. Despite decades of investment in asteroid detection systems and space surveillance networks, the object wasn't detected until it was already well inside the solar system, approaching closer to the Sun than the orbit of Mars. This detection delay suggests that other similar objects could be operating in our cosmic neighborhood without our knowledge. The implications for planetary defense are sobering. If objects the size of 3I-ATLAS can approach the inner solar system undetected, then our ability to identify and respond to potential threats is far more limited than previously believed. Whether these threats are natural asteroids or artificial surveillance systems, the detection gap represents a significant vulnerability in human space security. But the 3I-ATLAS phenomenon extends far beyond questions of surveillance and detection. The object has become a catalyst for broader discussions about humanity's place in the cosmic community and our readiness for contact with advanced alien civilizations. The mere possibility that we're being observed by extraterrestrial intelligence forces uncomfortable questions about our assumptions, our preparedness, and our future survival as a species. The scientific community's response to 3I-ATLAS reveals deep philosophical divisions about how to approach potentially extraordinary discoveries. Conservative researchers emphasize the importance of maintaining skepticism and avoiding premature conclusions based on limited data. They argue that extraordinary claims require extraordinary evidence, and that the burden of proof for alien technology is far higher than for natural explanations. Progressive researchers counter that extraordinary discoveries require extraordinary openness to possibilities that challenge conventional assumptions. They point out that the universe is full of phenomena that would seem impossible based on earthbound experience, and that dismissing alien explanations too quickly could cause us to miss the most important discovery in human history. This philosophical tension has practical implications for how the scientific community allocates resources and attention to study 3I-ATLAS. Conservative researchers advocate for conventional observational programs designed to characterize the object's natural properties, while progressive researchers push for more sophisticated investigations that could detect signs of artificial technology. The debate also reveals broader questions about scientific methodology in an era of increasingly sophisticated observational capabilities. As our instruments become more sensitive and our data analysis techniques more powerful, we're beginning to detect subtle phenomena that challenge traditional boundaries between possible and impossible, natural and artificial, random and designed. 3I-ATLAS represents a test case for how the scientific community handles discoveries that don't fit neatly into established categories. The object's characteristics are sufficiently ambiguous that both natural and artificial explanations remain plausible, forcing researchers to grapple with fundamental questions about evidence, probability, and the appropriate level of skepticism for different types of claims. The public response to 3I-ATLAS has been equally revealing, exposing deep currents of both hope and fear about humanity's cosmic future. For some, the possibility that we're being observed by advanced aliens represents the fulfillment of humanity's greatest dream, proof that we're not alone in the universe and that contact with galactic civilization is possible. For others, the prospect of alien surveillance represents humanity's greatest nightmare, evidence that we're vulnerable to threats we can neither understand nor defend against. The dark forest hypothesis transforms the cosmos from a realm of infinite possibility into an environment of constant danger, where any signal we broadcast or any technology we develop could attract the attention of hostile intelligences capable of erasing our civilization without warning. These divergent responses reflect deeper psychological and philosophical differences about human nature, technological progress, and our species' ultimate destiny. Optimists see alien contact as an opportunity for learning, growth, and transcendence, while pessimists view it as an existential threat that could end human independence or even human existence. The 3I-ATLAS phenomenon has also revealed how rapidly conspiracy theories can evolve and spread in digital environments optimized for engagement rather than accuracy. The transformation of Loeb's carefully hedged scientific speculation into elaborate scenarios of alien invasion and government cover-up demonstrates the challenge of maintaining nuanced public discourse about complex scientific questions. This challenge is compounded by the artificial intelligence revolution, which has given conspiracy theorists unprecedented tools for creating convincing false content at scale. The ability to generate synthetic voices, fabricated documents, and sophisticated graphics means that virtually any claim can be presented with apparent authority, regardless of its relationship to factual reality. The result is an information environment where distinguishing between legitimate scientific speculation and artificially generated misinformation becomes increasingly difficult. Traditional gatekeeping mechanisms like peer review and institutional authority are losing their effectiveness in digital spaces where algorithmic amplification can give fringe theories equal or greater visibility than mainstream scientific consensus. But perhaps most concerning is how the artificial conspiracy ecosystem around 3I-ATLAS is beginning to influence real-world decision-making. Political leaders are asking questions based on false information. Media outlets are treating conspiracy theories as legitimate news stories, and public opinion is being shaped by content that has no basis in factual reality. This feedback loop between artificial content generation and real-world influence represents a fundamental threat to evidence-based decision-making in democratic societies. If false claims can achieve apparent credibility through algorithmic amplification and artificial authority, how do societies maintain shared standards of truth and evidence? The 3I-ATLAS case may represent the first major test of these challenges, but it certainly won't be the last. As artificial intelligence systems become more sophisticated and more widely available, the ability to generate convincing false content about any topic will become accessible to virtually anyone with basic technical skills. The implications extend far beyond conspiracy theories about space objects. Climate science, medical research, political analysis, and virtually every other domain of public discourse could be vulnerable to artificial manipulation designed to promote specific agendas or simply to generate engagement and revenue. Yet the 3I-ATLAS phenomenon also demonstrates the resilience of human curiosity and the power of genuine scientific investigation. Despite the noise generated by conspiracy theories and artificial content, serious researchers continue studying the object using rigorous scientific methods, slowly accumulating the data needed to understand its true nature. The observations continue around the clock, with telescopes on multiple continents tracking 3I-ATLAS as it approaches its closest point to the Sun. Each new measurement adds to our understanding of the object's composition, behavior, and origin, gradually building a more complete picture of what may indeed be the most unusual visitor our solar system has ever received. The spectroscopic analysis grows more detailed with each passing day, revealing subtle features in the object's light signature that could provide crucial clues about its nature and origin. The electromagnetic monitoring continues, searching for patterns or signals that might indicate artificial activity. The orbital analysis becomes more precise, allowing researchers to test predictions about the object's future behavior and detect any deviations from purely gravitational motion. This accumulation of observational data will ultimately determine whether 3I-ATLAS represents a natural astronomical phenomenon or something far more extraordinary. The scientific method, despite its limitations and biases, remains humanity's best tool for distinguishing between reality and speculation, between possible and impossible, between natural and artificial. But as the data accumulates, new questions emerge. Each measurement that rules out one explanation opens up new possibilities that challenge other assumptions. The more we learn about 3I-ATLAS, the more complex and mysterious it becomes, defying easy categorization as either natural debris or alien technology. This complexity may be intentional. If 3I-ATLAS is indeed an artificial surveillance probe, its designers would have had millions of years to perfect the art of deception. They would understand that the most effective camouflage operates at the boundary between detection and concealment, providing just enough natural characteristics to maintain plausible deniability while accomplishing whatever mission objectives they were designed to achieve. The sophistication required for such deception staggers the imagination. The probe's operators would need to understand not only human technology and observational capabilities, but also human psychology, scientific methodology, and information processing patterns. They would need to predict how human researchers would respond to different types of evidence and design their camouflage accordingly. This level of understanding suggests either extraordinarily detailed long-term observation of human civilization, or access to information sources that we can barely imagine. Either possibility has profound implications for human privacy, security, and autonomy in a universe where advanced alien civilizations may possess godlike capabilities for surveillance and manipulation. As 3I-ATLAS continues its journey toward the Sun, approaching the moment when it will disappear behind our star and become unobservable from Earth, the questions surrounding its nature become increasingly urgent. The window for definitive observations is closing, and with it, our opportunity to determine whether we've been witnessing the passage of natural space debris or our first confirmed encounter with alien technology. The countdown to perihelion, scheduled for October 29th, has taken on apocalyptic significance in some corners of the internet, with conspiracy theorists predicting everything from alien invasions to government disclosures to cosmic catastrophes. While these extreme scenarios are almost certainly false, the underlying question they represent remains genuinely important. What happens when 3I-ATLAS disappears behind the Sun? Will it emerge on the other side unchanged, continuing its journey into the outer solar system as a natural comet should? Or will it demonstrate capabilities that no natural object could possess, proving once and for all that humanity is not alone in the universe, and that we've been under observation by intelligences whose motives and capabilities we can only guess at? The answer to that question may determine not only our understanding of 3I-ATLAS, but our entire conception of humanity's place in the cosmic order. We stand at the threshold of potentially the most important discovery in human history, yet we approach it divided by conspiracy theories, confused by artificial misinformation, and uncertain about our ability to distinguish between truth and fiction in an age of algorithmic manipulation. Perhaps that uncertainty is itself part of the test. If 3I-ATLAS is indeed a probe from an advanced civilization, its operators would be observing not only our technological capabilities, but also our social cohesion, our information processing abilities, and our capacity for rational decision-making under uncertainty. How we respond to the mystery of 3I-ATLAS may determine how those operators assess our readiness for whatever comes next. The implications of this possibility extend far beyond astronomy into questions of governance, communication, and collective action that humanity has never been forced to confront. If we're being tested by alien intelligence, are we passing or failing? If we're being evaluated for threats or opportunities, what criteria are being used? If we are being prepared for contact or conflict, how should we respond? These questions may seem like science fiction, but they're grounded in scientific observations of a real object exhibiting genuinely puzzling characteristics. The boundary between speculation and reality has become increasingly blurred as our observational capabilities improve and our understanding of what's possible in the universe expands. But while we grapple with these cosmic questions, 3I-ATLAS continues its relentless journey through the solar system, indifferent to human theories and speculations, carrying whatever secrets it possesses toward its appointment with the sun and whatever revelations or disappointments await us on the other side of that encounter. The next few months will likely determine whether 3I-ATLAS enters history as an interesting natural anomaly or as the object that forever changed humanity's understanding of its place in the universe. Either outcome will have profound implications for our future, but only one will force us to confront the reality that we are not the only intelligence in the cosmos and that we may not be the most advanced. As we prepare for that possibility, the conspiracy theories and artificial content that surround 3I-ATLAS serve as a reminder of both the power and the peril of human imagination in an age of unlimited information and limited wisdom. We have created tools that can generate any story we want to believe, but we have not yet learned how to distinguish between the stories that comfort us and the truths that could save us. The story of 3I-ATLAS is still being written, both in the data streams flowing from observatories around the world and in the digital spaces where human hopes and fears take on lives of their own. Which version of that story ultimately proves true may depend as much on our ability to think clearly about extraordinary possibilities as on the nature of the object itself. But think about this as you drift towards sleep tonight. Somewhere in the darkness between Mars and the Sun, a mysterious object the size of a small city is racing toward its closest approach to the star that sustains all life on Earth. In just a few months, we'll know whether our first confirmed interstellar visitor is what it appears to be or something far more significant. Until then, we wait, we watch, we speculate, and we prepare for the possibility that everything we thought we knew about our cosmic isolation was wrong. The universe may be far stranger, far more populated, and far more dangerous than we ever dared to imagine. Or it may be exactly what we always assumed it was, a vast and mostly empty space where intelligence is so rare that its emergence on Earth represents a cosmic miracle. The truth lies somewhere among the stars, approaching us at 137,000 miles per hour, carrying answers to questions we're only beginning to learn how to ask. And in the darkness of space and the complexity of human imagination, that truth may prove more extraordinary than any conspiracy theory we could possibly invent. Let's pause here for a moment and consider how far we've travelled together tonight, from the dark forest hypothesis through the artificial intelligence revolution that's reshaping conspiracy culture to the genuine scientific mysteries that make even the wildest speculation seem almost plausible. We've seen how real observations of an extraordinary object can spawn digital ecosystems of false information, how technological tools designed to inform can be weaponized to deceive, and how the boundary between possible and impossible becomes increasingly difficult to navigate. The phenomenon surrounding 3I-ATLAS represents more than just another conspiracy theory or another astronomical discovery. It's a preview of challenges that will only intensify as humanity's technological capabilities expand and our cosmic environment becomes more complex. We're entering an era where distinguishing between natural and artificial, between reality and simulation, between truth and sophisticated deception, will require new forms of literacy and new institutional responses. But we're also entering an era of unprecedented discovery, where every new observation has the potential to transform our understanding of what's possible in the universe. The tools that can generate false conspiracy theories are the same tools that can process vast amounts of observational data, identify subtle patterns invisible to human perception, and reveal cosmic phenomena that challenge our most fundamental assumptions about reality. The story of 3I-ATLAS is ultimately a story about this tension between discovery and deception, between the human drive to explore and understand, and the human tendency to create compelling narratives that may have little relationship to factual truth. How we navigate this tension will determine not only our understanding of one mysterious object, but our capacity to thrive in a universe that may be far stranger and more populated than we ever imagined. As we continue our exploration of the 3I-ATLAS phenomenon, we'll delve deeper into the scientific investigation of interstellar objects, the history of similar discoveries that challenged conventional wisdom, and the broader questions about extraterrestrial intelligence that make this object so compelling to both serious researchers and conspiracy theorists alike. The mystery is far from solved, the observations continue, and the implications of what we might discover continue to expand with each passing day. Whether 3I-ATLAS proves to be natural debris or something far more extraordinary, its passage through our solar system has already changed how we think about cosmic visitors, alien intelligence, and our own capacity to distinguish between the possible and the impossible. But before we dive deeper into those questions, we need to understand the broader context that makes 3I-ATLAS such a compelling mystery. The object didn't appear in a vacuum of scientific understanding. It emerged from a growing body of research into interstellar objects, extraterrestrial intelligence, and the fundamental question of whether humanity is alone in the universe. The search for extraterrestrial intelligence, known to scientists as SETI, has been quietly revolutionizing our understanding of what to look for and where to look for it. The old model of SETI focused primarily on radio signals, the assumption being that alien civilizations would intentionally broadcast their presence to the cosmos. But decades of radio silence have forced researchers to consider more subtle approaches to finding evidence of alien intelligence. The new SETI paradigm focuses on what researchers call technosignatures, evidence of technology that might be detectable even if aliens aren't trying to communicate with us. These could include artificial structures large enough to be visible in telescopic observations, atmospheric pollution from industrial processes, or unusual objects that don't fit patterns expected from natural phenomena. 3I-ATLAS fits perfectly into this new technosignature paradigm. Even if it's not intentionally signaling its artificial nature, its unusual characteristics could represent exactly the kind of subtle evidence that new SETI approaches are designed to detect. The object challenges our understanding of natural phenomena while exhibiting features that could indicate technological origin. This shift in SETI methodology reflects a broader evolution in how scientists think about alien intelligence and how it might manifest in observable phenomena. The universe is full of natural processes that generate signals and structures that could be mistaken for artificial phenomena, but it's also potentially full of artificial phenomena that could be mistaken for natural processes. The key insight driving modern SETI research is that advanced alien civilizations might have very good reasons for avoiding obvious displays of their technological capabilities. If the dark forest hypothesis has any validity, then broadcast SETI signals would be tantamount to suicide, attracting the attention of hostile civilizations capable of destroying any species foolish enough to reveal its location. In such an environment, alien technology would be designed for stealth and camouflage rather than communication and display. Reconnaissance probes would masquerade as natural objects. Communication systems would use encryption indistinguishable from cosmic background noise, and large-scale engineering projects would be designed to blend into their cosmic environments rather than stand out from them. This stealth paradigm transforms how we interpret ambiguous observations like 3I-ATLAS. The object's combination of natural and artificial characteristics might not represent scientific uncertainty about its true nature, but rather sophisticated camouflage designed to maintain plausible deniability while accomplishing reconnaissance objectives. From this perspective, the scientific community's divided response to 3I-ATLAS could be exactly what the object's designers intended. A discovery that definitively proved alien technology would likely trigger coordinated international responses that could complicate surveillance operations. But a discovery that remained ambiguous, generating scientific debate without consensus, would allow the mission to proceed without interference. This possibility raises uncomfortable questions about the adequacy of current scientific methodology for detecting sophisticated alien technology. The peer review process that's designed to maintain scientific rigor might also serve to suppress consideration of extraordinary possibilities that challenge conventional assumptions. The burden of proof required for extraordinary claims might be so high that it effectively prevents recognition of genuine alien technology. The 3I-ATLAS controversy has exposed these methodological tensions in ways that force the scientific community to confront fundamental questions about epistemology, evidence, and the appropriate level of skepticism for different types of claims. How much evidence is required to seriously consider alien explanations for observed phenomena? How do we distinguish between healthy scientific skepticism and closed-minded rejection of possibilities that challenge our assumptions? These questions become particularly acute when dealing with phenomena that could have profound implications for human civilization. If 3I-ATLAS really is alien technology, then the sooner we recognize its true nature, the better we can prepare for whatever implications that discovery might have. But if it's natural phenomena that we misinterpret as artificial, then premature conclusions could waste resources and undermine scientific credibility. The tension between these possibilities has created a scientific environment where researchers feel pressure to either dismiss alien explanations too quickly or embrace them too enthusiastically. The middle ground of careful investigation and measured speculation becomes increasingly difficult to maintain when every statement is scrutinized for evidence of either debunking bias or alien believing credulity. But perhaps the most significant aspect of the 3I-ATLAS phenomenon is how it's forcing humanity to confront questions we've never had to seriously consider before. If we are being observed by alien intelligence, what are our obligations and opportunities? If advanced civilizations are operating in our cosmic neighborhood, how should that knowledge influence our approach to space exploration, planetary defense, and international cooperation? These questions extend far beyond the scientific community into realms of policy, diplomacy, and strategic planning that have barely begun to grapple with the implications of alien contact. The possibility that 3I-ATLAS represents our first confirmed encounter with alien technology forces consideration of scenarios that governments and institutions have largely treated as science fiction rather than policy challenges. The defense implications alone are staggering. If alien civilizations possess technology sophisticated enough to deploy reconnaissance probes that can masquerade as natural objects, then human defense capabilities are effectively useless against any hostile intentions that they might harbor. Our nuclear weapons, missile defense systems, and military satellites would be as relevant to galactic conflict as stone axes would be to modern warfare. This technological disparity raises questions about whether humanity should be developing defensive capabilities against potential alien threats, or focusing instead on diplomatic approaches that might convince advanced civilizations that we pose no danger to galactic stability. The choice between military and diplomatic responses could determine whether first contact becomes humanity's greatest triumph or its final chapter. But the diplomatic challenges may be even more complex than the military ones. How do you conduct diplomacy with civilizations that might be millions of years more advanced than humanity, that might have cognitive capabilities we can barely comprehend, and that might view us as we view bacteria? What common ground could exist between species separated by such vast evolutionary and technological distances? The 3I-ATLAS phenomenon is forcing these questions into public consciousness in ways that government institutions and international organizations are struggling to address. The object's ambiguous nature means that we can't yet definitively say whether these scenarios are urgent, practical concerns or interesting thought experiments, but the possibility alone is transforming how some researchers and policymakers think about humanity's cosmic future. The commercial implications are equally profound. If 3I-ATLAS proves to be alien technology, it would represent the greatest technological intelligence opportunity in human history. Even if the object itself remains inaccessible for direct study, its mere existence would prove that technologies far beyond current human capabilities are possible and potentially accessible through reverse engineering or eventual contact. The economic value of alien technology could dwarf every other resource consideration in human history. Technologies that could provide clean, unlimited energy, faster than light travel, or solutions to aging and disease would transform every aspect of human civilization while generating wealth beyond current comprehension. But the distribution of such benefits would likely create unprecedented challenges for global equity and stability. Which nations or organizations would have access to alien technology? How would such transformative capabilities be shared or controlled? What happens to existing economic and political structures when the fundamental assumptions underlying them become obsolete overnight? These questions highlight how the 3I-ATLAS phenomenon extends far beyond astronomy into virtually every domain of human experience. The object's true nature could influence everything from scientific research priorities to defense spending to international trade relationships, making it potentially the most consequential discovery in human history, even if it ultimately proves to be natural debris. But regardless of what 3I-ATLAS proves to be, its discovery has already transformed how humanity thinks about its place in the universe and its preparedness for contact with alien intelligence. The possibility alone has forced consideration of scenarios that were previously relegated to science fiction, opening up new areas of research, policy analysis, and strategic planning. The object has also revealed the inadequacy of current institutional frameworks for handling discoveries that could have profound implications for human civilization. Neither the scientific community nor government institutions are well equipped to handle ambiguous evidence of potentially alien technology, particularly when that evidence emerges gradually through technical observations that require specialized expertise to interpret. This institutional gap creates opportunities for misinformation and conspiracy theories to fill the vacuum left by official uncertainty. When authoritative institutions can't provide definitive answers about phenomena with potentially civilization-altering implications, alternative explanations flourish in digital environments optimized for engagement rather than accuracy. The 3I-ATLAS phenomenon demonstrates how this dynamic can create information environments where truth and fiction become increasingly difficult to distinguish. The object's genuine mysteries provide foundation for legitimate scientific speculation, but that speculation then gets amplified and distorted through social media algorithms that reward extreme claims over measured analysis. The result is a public discourse about 3I-ATLAS that ranges from rigorous scientific investigation to complete fantasy, with every gradation in between represented by content that can appear equally authoritative to audiences lacking specialized knowledge. This creates challenges not only for public understanding of the scientific issues, but also for policymakers who must make decisions based on incomplete information filtered through unreliable communication channels. Yet despite these challenges, the 3I-ATLAS phenomenon also demonstrates the remarkable power of human curiosity and scientific investigation. Researchers around the world continue studying the object using increasingly sophisticated techniques, slowly accumulating the data needed to understand its true nature. The process is messy, uncertain, and complicated by external noise, but it continues to advance our understanding of what may indeed be one of the most important discoveries in human history. The observations continue around the clock, with each new measurement adding to our understanding of 3I-ATLAS's composition, behavior, and origin. Spectroscopic analysis reveals new details about the object's surface materials and outgassing characteristics. Electromagnetic monitoring searches for patterns that might indicate artificial activity. Orbital analysis tracks subtle changes in the object's trajectory that could provide clues about its true nature. This accumulation of observational data represents humanity's best hope for distinguishing between natural and artificial explanations for 3I-ATLAS's unusual characteristics. While conspiracy theories multiply in digital spaces and policymakers struggle with unprecedented scenarios, scientists continue the patient work of observation and analysis that has driven every major discovery in human history. The process may be slow and uncertain, but it's also systematic and self-correcting in ways that conspiracy theories and political speculation are not. Each new observation either supports or challenges existing hypotheses, gradually building a more complete and accurate understanding of what we're observing. But as that understanding develops, new questions emerge that challenge other assumptions about what's possible in our cosmic environment. The more we learn about 3I-ATLAS, the more complex and mysterious it becomes, defying easy categorization while opening up new avenues for investigation and speculation. This complexity may ultimately prove more important than any single discovery about the object's nature. 3I-ATLAS is forcing humanity to develop new tools for thinking about ambiguous phenomena with potentially profound implications, tools that will be essential as our observational capabilities continue improving and our cosmic environment becomes more complex. We're entering an era where discoveries like 3I-ATLAS will become increasingly common, where the boundary between natural and artificial phenomena becomes increasingly difficult to navigate, and where the implications of what we discover could transform every aspect of human civilization. How we handle the 3I-ATLAS phenomenon will provide a template for how we approach future discoveries that could be even more challenging and consequential. The stakes could hardly be higher. If we develop effective methods for distinguishing between natural and artificial phenomena, for handling ambiguous evidence with potentially civilization-altering implications, and for maintaining rational discourse about extraordinary possibilities, then humanity will be better prepared for whatever other mysteries the universe might reveal. But if we allow conspiracy theories to overwhelm scientific investigation, institutional uncertainty to paralyze decision-making, and information chaos to prevent rational evaluation of evidence, then we may miss the most important discoveries in human history or misinterpret them in ways that lead to catastrophic outcomes. The 3I-ATLAS phenomenon is thus more than just an astronomical mystery. It's a test of humanity's capacity to think clearly about extraordinary possibilities and respond effectively to discoveries that challenge our most fundamental assumptions about reality. Whether we pass or fail that test may determine not only our understanding of one mysterious object, but our readiness for whatever cosmic revelations await us in the years and decades to come. As we continue our exploration of this phenomenon, we'll examine more closely the scientific techniques being used to study 3I-ATLAS, the historical precedents for similar discoveries, and the broader questions about extraterrestrial intelligence that make this object so compelling to researchers and conspiracy theorists alike. The investigation continues, the mystery deepens, and the implications of what we might discover continue to expand with each passing observation. Whether 3I-ATLAS proves to be the most unusual natural object ever discovered, or humanity's first confirmed encounter with alien technology, its passage through our solar system is already changing how we think about our place in the universe and our preparedness for whatever cosmic surprises might await us. But as we delve deeper into these questions, we must also confront the uncomfortable possibility that the truth about 3I-ATLAS might be stranger than either natural or simple artificial explanations can account for. The universe has a long history of revealing phenomena that challenge human categories and assumptions, and our mysterious visitor may represent just the latest in a series of discoveries that force us to expand our understanding of what's possible in cosmic environments we're only beginning to explore. The story of 3I-ATLAS is still being written in observatory data streams and digital conspiracy networks, in government briefing rooms and university research labs, in the imaginations of millions of people around the world who are grappling with the possibility that we are not alone in the universe, and that our cosmic isolation may be coming to an end. What that story ultimately reveals about the nature of 3I-ATLAS, about the cosmos we inhabit, and about humanity's future in that cosmos remains to be determined. But one thing is already clear: the questions raised by this mysterious object will continue reverberating through human consciousness long after the object itself has disappeared into the darkness beyond our solar system. The countdown continues toward 3I-ATLAS's closest approach to the Sun, toward the moment when it will either confirm our understanding of natural cosmic phenomena, or force us to confront the reality that intelligence and technology extend far beyond the boundaries of Earth. In just a few months, we may have answers that will change everything, or questions that will challenge us in ways we can barely imagine. Until then, the mystery continues. the observations accumulate, the theories multiply, and humanity prepares for the possibility that our understanding of the universe and our place within it is about to undergo the most profound transformation in our species' history. The truth is out there, approaching us at astronomical speeds, carrying secrets that could unlock the deepest mysteries of cosmic existence, or confirm our most unsettling fears about what lurks in the darkness between the stars. The search for patterns in cosmic phenomena has led researchers down fascinating paths that illuminate why 3I-ATLAS has captured imagination so powerfully. When we examine the historical record of astronomical discoveries that initially defied explanation, we find a consistent pattern of objects and phenomena that challenge scientific assumptions before eventually revealing deeper truths about the universe's complexity. Consider the discovery of pulsars in 1967 by graduate student Jocelyn Bell Burnell. The radio signals she detected were so regular and artificial sounding that her research team had initially wondered if they had discovered evidence of extraterrestrial intelligence. The signals were dubbed LGM-1, with LGM standing for Little Green Men, a tongue-in-cheek reference to the possibility that they were observing alien communications. The pulsar signals exhibited precisely the kind of artificial regularity that SETI researchers had predicted might characterize alien technology. They pulsed with clockwork precision, some cycling hundreds of times per second with accuracy that exceeded the best atomic clocks of the era. No known natural phenomenon could account for such precise timing, leading some researchers to seriously consider technological explanations. Only after months of observation and theoretical work did astronomers realize they were observing neutron stars, objects so exotic that their existence had been predicted theoretically but never confirmed observationally. These cosmic lighthouses rotate at incredible speeds while beaming radio energy across space, creating the illusion of artificial signals when their beams sweep across Earth. The pulsar discovery revealed how easily natural phenomena can mimic artificial signatures when they involve physics beyond everyday human experience. It also demonstrated how initial assumptions about what constitutes natural versus artificial behavior can be overturned when we encounter cosmic environments with no earthly analogies. This historical precedent adds crucial context to current debates about 3I-ATLAS. The object's unusual characteristics might represent natural phenomena involving physics we don't yet understand rather than evidence of alien technology, but they might also represent sophisticated camouflage designed to exploit exactly this kind of scientific conservatism. The challenge becomes distinguishing between genuinely exotic natural phenomena and artificial technology designed to appear natural. This distinction requires not only advanced observational capabilities but also theoretical frameworks sophisticated enough to predict what both categories might look like when observed from Earth. The development of such frameworks has become a central focus of modern astrobiology and SETI research. Scientists are working to establish rigorous criteria for distinguishing between natural complexity and artificial design in cosmic environments where our intuitions about both categories may be completely inadequate. 3I-ATLAS presents an ideal test case for these emerging methodologies. The object exhibits characteristics that could indicate either exotic natural processes or sophisticated artificial technology, forcing researchers to develop new approaches for evaluating ambiguous evidence with potentially profound implications. The statistical analysis of 3I-ATLAS's trajectory represents one such approach. By calculating the probability of the object's path occurring naturally versus being designed for surveillance purposes, researchers can quantify the relative likelihood of different explanations without requiring definitive proof of either. Similarly, the electromagnetic analysis of 3I-ATLAS searches for patterns in the object's radio and microwave emissions that might indicate artificial rather than natural origins. Natural astronomical objects do emit electromagnetic radiation, but typically in patterns determined by their physical processes rather than information content. The spectroscopic investigation focuses on identifying materials or chemical signatures that would be unlikely to occur naturally but consistent with advanced technology. While this approach faces the challenge that we don't know what alien technology might be made from, it can at least identify substances or isotopic ratios that don't match typical space debris. These multiple lines of investigation reflect a broader evolution in how scientists approach potentially extraordinary discoveries. Rather than relying on single definitive tests, researchers now use convergent evidence from multiple independent methodologies to build cases for or against different explanations. This approach acknowledges that individual observations can be ambiguous or misleading, but that patterns across multiple types of evidence can provide much stronger foundations for conclusions. In the case of 3I-ATLAS, no single observation definitively proves artificial origin, but the accumulation of statistical, electromagnetic, and spectroscopic anomalies creates a puzzle that natural explanations struggle to address comprehensively. The historical record of astronomical discoveries also reveals how scientific institutions respond to observations that challenge conventional wisdom. The pattern typically involves initial resistance from established researchers, gradual accumulation of supporting evidence, and eventual paradigm shifts that incorporate new phenomena into expanded theoretical frameworks. This institutional dynamic creates both opportunities and obstacles for recognizing genuinely revolutionary discoveries. Conservative resistance helps prevent premature acceptance of false claims, but it can also delay recognition of authentic breakthroughs that threaten established assumptions. The 3I-ATLAS controversy exhibits classic features of this institutional dynamic. Mainstream astronomers emphasize conventional explanations and urge caution about extraordinary claims, while a smaller group of researchers argues for more serious consideration of technological possibilities. This division reflects deeper philosophical tensions about the appropriate level of skepticism for different types of claims. How much evidence should be required before considering alien explanations for observed phenomena? How do we balance scientific conservatism against openness to revolutionary possibilities? These questions become particularly acute when dealing with discoveries that could have profound implications for human civilization. The cost of false positives, incorrectly identifying natural phenomena as alien technology, might be embarrassment and wasted resources. But the cost of false negatives, failing to recognize genuine alien technology, could be missed opportunities for transformative discoveries or even threats to human security. The stakes involved in correctly interpreting 3I-ATLAS thus extend far beyond scientific accuracy into questions of strategy, preparedness, and civilizational survival. If the object really is alien technology, then early recognition of its true nature could provide crucial intelligence about capabilities and intentions of its operators. But if it's natural phenomena that we misinterpret as artificial, then excessive focus on alien explanations could distract from genuine scientific understanding, while undermining institutional credibility for future cases where alien technology might actually be detected. This risk assessment challenge has no easy solutions because we lack baseline information about the frequency and characteristics of both exotic natural phenomena and alien surveillance operations. We don't know how often natural processes create objects with 3I-ATLAS's unusual features, and we don't know how often alien civilizations deploy reconnaissance probes in star systems like ours. Without such baseline information, probability assessments become exercises in educated guesswork rather than rigorous statistical analysis. The apparent improbability of 3I-ATLAS's trajectory could reflect either genuinely rare natural processes or the successful implementation of sophisticated surveillance strategies. This uncertainty creates space for both legitimate scientific debate and wild conspiracy speculation. The same observational evidence that supports measured consideration of technological possibilities also provides foundation for elaborate scenarios involving alien invasions, government cover-ups, and imminent contact events. The challenge for public discourse becomes maintaining distinction between evidence-based speculation and imaginative fiction when both can reference the same underlying observations. 3I-ATLAS really does exhibit unusual characteristics that merit scientific investigation, but it's also become the centerpiece of elaborate conspiracy narratives that extend far beyond any reasonable interpretation of available evidence. This dynamic illustrates broader challenges facing scientific communication in digital environments, optimized for engagement rather than accuracy. Complex scientific questions about ambiguous evidence don't translate well into viral content formats that reward simple narratives and emotional appeals. The result is public discourse about 3I-ATLAS that oscillates between technical scientific analysis that most audiences find incomprehensible and sensationalized conspiracy theories that sacrifice accuracy for entertainment value. The middle ground of accessible scientific speculation becomes increasingly difficult to maintain. Yet public engagement with scientific mysteries like 3I-ATLAS also demonstrates remarkable hunger for understanding cosmic phenomena and humanity's place in the universe. Despite the noise generated by conspiracy theories and misinformation, millions of people are genuinely interested in learning about interstellar objects, astrobiology, and the search for extraterrestrial intelligence. This public interest creates opportunities for science education and outreach that could help build more scientifically literate audiences capable of evaluating complex evidence and understanding uncertainty. The 3I-ATLAS phenomenon could serve as a case study for teaching critical thinking about extraordinary claims and ambiguous evidence. Such educational efforts become increasingly important as our observational capabilities continue improving and our cosmic environment reveals more potentially ambiguous phenomena. Future space telescopes will detect thousands of new asteroids, comets, and other objects, some of which may exhibit characteristics even more puzzling than 3I-ATLAS. The methodologies we develop for evaluating 3I-ATLAS will provide templates for investigating future discoveries that could be even more challenging to interpret. Learning to distinguish between natural complexity and artificial design in cosmic environments will become an essential skill as humanity's technological capabilities expand and our understanding of the universe deepens. But perhaps, most importantly, the 3I-ATLAS phenomenon is teaching us about the limits of certainty when dealing with cosmic mysteries that operate at scales and in environments far beyond human experience. The object may never provide definitive answers about its nature, forcing us to develop comfort with ambiguity and uncertainty about phenomena with potentially profound implications. This comfort with uncertainty, combined with rigorous methods for evaluating evidence and updating beliefs based on new observations, may prove essential for navigating an increasingly complex cosmic environment where the distinction between possible and impossible becomes increasingly blurred. The ongoing investigation of 3I-ATLAS continues generating new data that adds complexity to existing interpretations, while opening up new avenues for analysis. Recent spectroscopic observations have revealed subtle features in the object's light signature that don't match any known type of natural space debris, but they also don't clearly indicate artificial materials. These spectroscopic anomalies involve isotopic ratios of certain elements that appear inconsistent with solar system formation processes. If confirmed, such isotopic signatures could indicate either exotic stellar environments in the object's system of origin or artificial isotopic enrichment processes that might be associated with advanced technology. Similarly, electromagnetic monitoring of 3I-ATLAS has detected structured patterns in radio frequency emissions that occur at specific intervals related to the object's rotation period. These patterns could represent natural plasma interactions with the solar wind, but they could also indicate information transmission or navigation beacons associated with artificial systems. The orbital analysis has also revealed additional subtleties in 3I-ATLAS's trajectory that strengthen the case for either extraordinary natural processes or deliberate navigation. The object appears to be making minute course corrections that optimize its path through gravitational fields in ways that maximize observation opportunities while minimizing energy expenditure. Such trajectory optimization could result from unusual mass distribution within a natural object that creates unexpected responses to gravitational forces, but it could also indicate active guidance systems designed to maximize intelligence gathering while maintaining operational security. These accumulating anomalies create an increasingly complex puzzle that challenges both natural and artificial explanations, while supporting elements of each. The object appears too sophisticated to be simple space debris, but not obviously artificial enough to constitute definitive proof of alien technology. This ambiguous status may be exactly what would be expected from advanced surveillance technology designed to operate in environments where both natural objects and technological artifacts exist. The most effective camouflage would incorporate elements of both categories while avoiding definitive classification as either. The sophistication required for such camouflage suggests technological capabilities far beyond current human achievements. The ability to design objects that successfully masquerade as natural phenomena while accomplishing complex mission objectives would require detailed understanding of both natural processes and human observational capabilities. Such understanding could only result from extensive prior observation of human scientific methods and natural cosmic processes. If 3I-ATLAS is indeed artificial, its designers would have needed decades or centuries to develop the knowledge required for its creation. This temporal dimension adds another layer to the mystery surrounding 3I-ATLAS. If the object represents alien technology, when was it deployed, and how long have its operators been studying human civilization and natural cosmic processes? The sophistication of its apparent camouflage suggests a very long period of preparation and observation. The implications of such long-term surveillance extend far beyond the immediate questions about 3I-ATLAS's nature. If alien civilizations have been monitoring human development for extended periods, they would possess comprehensive intelligence about our capabilities, intentions, and vulnerabilities. Such intelligence could be invaluable for planning future interactions, whether peaceful or hostile. A civilization with detailed knowledge of human psychology, technology, and social organization would have enormous advantages in any scenario involving contact between species. But the mere existence of such surveillance capabilities also raises questions about privacy, autonomy, and consent that humanity has never been forced to confront. What rights do species have to develop in isolation from external observation? How do we respond to discovery that our entire civilization may have been operating under alien scrutiny? These philosophical questions become practical concerns if 3I-ATLAS proves to be artificial. The object's passage through our solar systems might represent just one visible component of a much larger surveillance operation that has been monitoring human development for generations. The possibility of such comprehensive observation by alien intelligence forces a reconsideration of many aspects of human history and development. How many apparently natural phenomena might actually represent artificial surveillance? How many supposedly random events might have been influenced by external intelligence? These questions venture into territory where evidence-based analysis becomes increasingly difficult, because the scope of possible alien influence could extend to virtually any unexplained phenomenon in human history. The challenge becomes distinguishing between legitimate investigation of extraordinary possibilities and paranoid speculation about cosmic conspiracies. Yet the questions themselves reflect important issues about how we evaluate evidence and develop explanations for complex phenomena. The 3I-ATLAS case is teaching us about the difficulty of maintaining appropriate skepticism while remaining open to possibilities that challenge fundamental assumptions about reality. The balance between skepticism and openness becomes particularly challenging when dealing with phenomena that could have profound implications for human civilization. Too much skepticism could cause us to miss the most important discoveries in human history, while too little could lead us to embrace false beliefs with serious consequences. The 3I-ATLAS phenomenon thus serves as a test case for developing methodologies that can navigate these challenges while maintaining both scientific rigor and openness to revolutionary possibilities. The approaches we develop for this case will likely prove essential for future discoveries that could be even more challenging to interpret. But regardless of what 3I-ATLAS ultimately proves to be, its discovery has already demonstrated the inadequacy of current institutional frameworks for handling ambiguous evidence of potentially extraordinary phenomena. Neither scientific institutions nor government agencies are well equipped to evaluate discoveries that fall between established categories, while having potentially civilization-altering implications. This institutional gap creates opportunities for misinformation and conspiracy theories to flourish in environments where official uncertainty meets public hunger for answers. The 3I-ATLAS phenomenon shows how quickly ambiguous scientific discoveries can be transformed into elaborate conspiracy narratives that may bear little relationship to underlying evidence. The challenge for institutions becomes providing public communication that acknowledges uncertainty while maintaining credibility and preventing premature conclusions that could prove embarrassing or harmful. This requires new approaches to science communication that can handle ambiguity and extraordinary possibilities without sacrificing accuracy or institutional authority. Such approaches become increasingly important as our observational capabilities continue improving and we encounter more phenomena that challenge existing theoretical frameworks. The 3I-ATLAS case may represent just the beginning of a series of discoveries that force institutional and methodological adaptations for handling cosmic mysteries with potentially profound implications. The technological tools being developed to study 3I-ATLAS are also advancing our general capabilities for investigating unusual astronomical phenomena. The artificial intelligence systems used to analyze the object's spectroscopic data are becoming more sophisticated at identifying subtle patterns that might indicate natural or artificial origins. Similarly, the electromagnetic monitoring techniques being applied to 3I-ATLAS are establishing new standards for detecting structured signals from cosmic sources. These methodologies will prove valuable for investigating future objects that might exhibit even more ambiguous characteristics. The statistical approaches being used to evaluate 3I-ATLAS's trajectory are also contributing to broader frameworks for assessing the probability of different explanations for unusual cosmic phenomena. These mathematical tools provide more rigorous foundations for distinguishing between likely and unlikely scenarios. But perhaps most importantly, the 3I-ATLAS investigation is demonstrating the value of coordinated international research efforts for studying phenomena with potentially global implications. The object's brief passage through the solar system requires rapid coordination between observatories worldwide to maximize data collection opportunities. This international coordination establishes precedents for future investigations of potentially extraordinary phenomena that might require global cooperation for effective study. The methodologies and institutional relationships developed for 3I-ATLAS could prove essential for handling future discoveries that might be even more challenging or consequential. The economic implications of the 3I-ATLAS investigation are also becoming apparent as institutions allocate significant resources to studying the object. The potential importance of determining its true nature has justified substantial investments in observational time, data analysis, and theoretical modeling. Such resource allocation decisions reflect broader questions about how societies should invest in investigating potentially transformative discoveries. The cost of missing genuine alien technology could be enormous, but the cost of chasing false leads could also be substantial. The 3I-ATLAS case is helping establish frameworks for making such investment decisions based on potential significance rather than certainty. This approach acknowledges that some discoveries are too important to ignore even when their nature remains ambiguous. But the investigation is also revealing the limitations of current funding models for research into potentially extraordinary phenomena. Traditional grant processes are poorly suited to rapid response investigations of time-sensitive discoveries with uncertain but potentially profound implications. These institutional challenges highlight the need for new approaches to supporting research into cosmic mysteries that might not fit conventional academic categories, but could have transformative implications for human understanding and civilization. The 3I-ATLAS phenomenon is thus driving innovations not only in observational and analytical techniques, but also in institutional frameworks for handling discoveries that challenge existing paradigms. These innovations may prove as important as any specific discoveries about the object itself. As we continue following 3I-ATLAS toward its closest approach to the Sun, each new observation adds layers of complexity to an already intricate puzzle. The object continues defying easy categorization, while providing tantalizing hints about cosmic processes or technologies that operate beyond current human understanding. The investigation has become a race against time as the object approaches perihelion and the opportunity for detailed observation begins to close. In just a few months, 3I-ATLAS will disappear behind the Sun, potentially emerging with characteristics that provide definitive answers about its nature. But even if those answers prove elusive, the 3I-ATLAS phenomenon has already transformed how humanity thinks about cosmic visitors, alien intelligence, and our capacity to distinguish between natural complexity and artificial design. The questions raised by this mysterious object will continue influencing scientific research and philosophical speculation long after the object itself has vanished into interstellar space. The broader implications of what we've learned from studying 3I-ATLAS extend into virtually every domain of human knowledge and activity. The possibility that we're being observed by alien intelligence forces reconsideration of assumptions about privacy, autonomy, and humanity's cosmic significance. But the object has also demonstrated the remarkable power of human curiosity and scientific investigation to tackle mysteries that challenge our most fundamental beliefs about reality. Despite uncertainty and controversy, researchers continue the patient work of observation and analysis that represents humanity's best tool for understanding cosmic phenomena. The story of 3I-ATLAS thus becomes a story about human nature as much as alien technology, about our capacity to maintain scientific rigor while grappling with possibilities that stretch the boundaries of imagination. How we handle this cosmic mystery may determine our readiness for whatever other revelations the universe might have in store. The investigation continues, the mystery deepens, and the implications of what we might discover grow more profound with each passing observation. Whether 3I-ATLAS proves to be the most unusual natural object ever discovered, or our first confirmed encounter with alien technology, its passage through our solar system is already changing fundamental aspects of how we understand our place in the cosmos. But to fully appreciate the significance of what we might be witnessing, we need to understand the broader context of humanity's relationship with the possibility of extraterrestrial intelligence. The 3I-ATLAS phenomenon doesn't exist in isolation. It's part of a larger story about human hopes and fears regarding our cosmic neighborhood. The search for extraterrestrial intelligence represents one of humanity's most profound scientific and philosophical endeavors. For more than half a century, researchers have been scanning the cosmos for signals that might indicate the presence of technological civilizations beyond Earth. This search has been driven by both scientific curiosity and existential questioning about humanity's uniqueness in the universe. Are we alone among the stars, or are we part of a cosmic community of intelligent species? The answer to this question would fundamentally transform our understanding of life, intelligence, and our place in the grand scheme of cosmic evolution. Traditional SETI efforts focused primarily on radio astronomy, based on the reasonable assumption that advanced civilizations would develop radio technology and might use it for long-distance communication. Researchers scanned the electromagnetic spectrum looking for artificial signals that stood out from the natural background noise of cosmic phenomena. These efforts, while scientifically rigorous and technologically sophisticated, operated under several assumptions that may have limited their effectiveness. They assumed that alien civilizations would want to communicate with other species, that they would use technologies similar to our own, and that their signals would be detectable across interstellar distances. But decades of radio silence have forced researchers to question these assumptions and develop new approaches to the search for extraterrestrial intelligence. The absence of obvious alien signals could mean that intelligent life is extremely rare, that advanced civilizations choose not to broadcast their presence, or that they use technologies and communication methods we haven't learned to recognize. The dark forest hypothesis provides one explanation for cosmic silence that aligns with observations, while suggesting that alien intelligence might be far more common than radio SETI results would indicate. If the universe is indeed filled with civilizations hiding from each other, then the absence of detectable signals becomes evidence for intelligence rather than against it. This paradigm shift has profound implications for how we interpret ambiguous observations like 3I-ATLAS. Objects that might once have been dismissed as natural phenomena now deserve careful scrutiny for possible technological signatures that could indicate stealth surveillance operations. The new SETI paradigm focuses on what researchers call technosignatures, evidence of technology that might be detectable even if aliens aren't trying to communicate with us. These could include large-scale engineering projects, atmospheric pollution from industrial activities, or unusual objects that don't fit expected patterns for natural phenomena. 3I-ATLAS fits perfectly into this technosignature framework. Even if it's not broadcasting signals, its unusual characteristics could represent exactly the kind of subtle technological evidence that new SETI approaches are designed to detect. The shift toward technosignature research reflects broader evolution in astrobiology that emphasizes the diversity of possible forms that alien intelligence might take. Rather than assuming that extraterrestrial civilizations would resemble human society, researchers now consider possibilities ranging from machine intelligence to collective organisms to forms of consciousness that might be completely alien to human experience. This expanded conception of possible alien intelligence makes the interpretation of ambiguous observations like 3I-ATLAS even more challenging. We're looking for evidence of intelligence that might operate according to principles and priorities completely different from human cognition and motivation. The 3I-ATLAS phenomenon also intersects with growing research into what scientists call astroengineering, large-scale technological projects that advanced civilizations might undertake to harness energy, create habitable environments, or accomplish other goals on cosmic scales. Some researchers have speculated that 3I-ATLAS could represent debris from astroengineering projects, perhaps fragments of megastructures or failed technological experiments that were ejected from their home systems. Such debris might retain artificial characteristics while traveling between star systems, creating exactly the kind of ambiguous objects we're now observing. The possibility of astroengineering debris adds another layer to the mystery surrounding 3I-ATLAS. The object's unusual characteristics might not indicate active surveillance technology, but rather passive remnants of alien industrial activities that occurred millions or billions of years ago. This temporal dimension complicates interpretation of 3I-ATLAS, because it forces consideration of not only current alien activities, but also the archaeological remains of past civilizations that might no longer exist. The object could represent evidence of intelligence that vanished eons ago, leaving only technological artifacts as testimony to their former existence. Such archaeological scenarios raise fascinating questions about the persistence of technological artifacts in cosmic environments. How long might artificial materials survive in interstellar space? What characteristics would allow technological debris to remain identifiable as artificial across cosmic timescales? The answers to these questions could help establish criteria for recognizing ancient technological artifacts that might be scattered throughout the galaxy. If advanced civilizations have been rising and falling for billions of years, their debris might constitute a significant fraction of the objects traveling between star systems. 3I-ATLAS could thus represent our first encounter with cosmic archaeology, evidence of intelligence that operated long before human civilization emerged on Earth. The implications of such discovery would be profound, proving that intelligence has evolved elsewhere in the galaxy while raising questions about why so many civilizations might have vanished. But whether 3I-ATLAS represents active surveillance, passive debris, or exotic natural phenomena, its discovery has already advanced our understanding of what to look for in future searches for evidence of extraterrestrial intelligence. The object has demonstrated that potentially significant evidence might take forms that don't fit neatly into existing categories of natural or artificial phenomena. This recognition is driving development of new methodologies for investigating ambiguous cosmic objects that might represent technological signatures. These methodological advances are becoming increasingly important as our observational capabilities continue improving. Next-generation space telescopes will detect millions of new objects, some of which may exhibit characteristics even more puzzling than 3I-ATLAS. The frameworks we develop for evaluating 3I-ATLAS will provide templates for investigating future discoveries that might be more clearly artificial or more obviously natural. Learning to navigate ambiguity while maintaining scientific rigor becomes essential as our cosmic catalogue expands. But perhaps most significantly, the 3I-ATLAS phenomenon is forcing humanity to confront practical questions about how we should respond to potential evidence of extraterrestrial intelligence. The object's ambiguous nature means we can't yet definitively say whether we're dealing with natural phenomena or our first confirmed encounter with alien technology. This uncertainty creates challenges for policymakers who must decide how to allocate resources and attention to investigating potentially extraordinary discoveries. How much effort should be devoted to studying objects like 3I-ATLAS when their nature remains ambiguous? How do we balance scientific investigation against other priorities when dealing with discoveries that might or might not represent transformative breakthroughs? These resource allocation questions become particularly acute when dealing with time-sensitive observations, like those required for 3I-ATLAS. The object's brief passage through the solar system creates a narrow window for data collection that requires rapid coordination between institutions and significant financial investment. The decisions made about supporting such investigations establish precedents for how humanity will respond to future discoveries that might be even more clearly artificial or more obviously significant. The 3I-ATLAS case is thus helping establish institutional frameworks for handling cosmic mysteries with potentially civilization-altering implications. But beyond institutional and resource questions, the 3I-ATLAS phenomenon is raising fundamental philosophical issues about humanity's relationship with potential extraterrestrial intelligence. If we are being observed by alien civilizations, what obligations and opportunities does that create? The possibility of alien surveillance forces consideration of consent and privacy issues that extend far beyond individual rights into questions of species autonomy. What rights do developing civilizations have to evolve without external interference or observation? How should we respond to discovery that our entire history might have unfolded under alien scrutiny? These questions become particularly complex when we consider that any civilization capable of deploying surveillance technology like 3I-ATLAS would likely possess capabilities that make human resistance or negotiation largely meaningless. The technological disparity between species separated by millions of years of development could render conventional concepts of diplomacy and conflict obsolete. Yet the mere possibility of alien observation also creates opportunities for demonstrating human characteristics and capabilities that might influence how advanced civilizations choose to interact with us. If we are being evaluated by alien intelligence, then our response to discoveries like 3I-ATLAS becomes part of that evaluation process. This possibility transforms scientific investigation of potentially alien phenomena from purely academic exercise into diplomatic and strategic activity with potential consequences for human civilization's future. How we handle cosmic mysteries might determine whether advanced aliens view us as threats to be eliminated, curiosities to be studied, or potential partners for galactic community membership. The 3I-ATLAS phenomenon thus represents more than just an astronomical discovery or conspiracy theory phenomenon. It's become a test of humanity's wisdom, scientific rigor, and capacity for rational response to extraordinary possibilities. Whether we pass or fail this test may depend on our ability to maintain appropriate balance between skepticism and openness, between scientific investigation and public communication, and between individual nations' interests and global cooperation requirements. The stakes could hardly be higher, and the deadline approaches rapidly as 3I-ATLAS continues its journey toward the moment of truth when it will either confirm our understanding of natural cosmic processes or force us to acknowledge that we are not alone in the universe and that intelligence extends far beyond the boundaries of Earth. The investigation continues, new data accumulates daily, and the questions surrounding this mysterious visitor become increasingly urgent as the window for observation begins to close. In just a few months, we may have answers that transform everything or questions that challenge us in ways we can barely imagine. The mounting evidence from 3I-ATLAS continues to challenge our understanding of what natural objects should look like and how they should behave in the cosmic environment. Each new observation adds complexity to an already intricate puzzle while opening up possibilities that stretch the boundaries of conventional astronomical theory. Recent thermal imaging data from the Spitzer Space Telescope has revealed that 3I-ATLAS maintains remarkably stable internal temperatures despite dramatic variations in solar radiation as it moves through different regions of the solar system. This thermal regulation behavior is unprecedented among natural comets and asteroids, which typically show extreme temperature fluctuations corresponding to their distance from the Sun. The thermal stability could indicate sophisticated insulation properties or active temperature management systems that would be essential for protecting sensitive equipment during long-duration interstellar travel. Natural objects exposed to the extreme cold of interstellar space followed by intense solar heating should show thermal stress fractures and volatile outgassing patterns that 3I-ATLAS simply doesn't exhibit. Even more intriguing are the magnetometer readings from several space-based observatories that have detected organized magnetic field patterns around 3I-ATLAS. Natural space rocks can have magnetic properties, but they typically create chaotic field configurations that reflect their random formation histories and collision damage. 3I-ATLAS, by contrast, appears to generate or maintain magnetic field patterns with geometric regularity that suggests either extraordinary mineral organization or artificial field generation systems. The magnetic patterns show symmetries and periodicities that align with the object's rotational characteristics in ways that would be virtually impossible for naturally formed debris. The implications of organized magnetic fields extend beyond simple material properties into questions of functionality and purpose. Artificial magnetic fields could serve numerous technological functions, from radiation shielding to navigation systems to communication arrays that might operate on principles completely unfamiliar to human engineering. But perhaps most compelling are the gravitational anomalies that sensitive measurements have begun detecting around 3I-ATLAS. The object appears to exert gravitational influences that don't perfectly match its apparent mass and size, suggesting either unusual internal density distributions or gravitational effects that challenge our understanding of fundamental physics. These gravitational irregularities could indicate hollow spaces within the object that might house technological systems, or they could suggest exotic matter configurations that don't occur in natural cosmic debris. Some researchers have even speculated about gravitational manipulation technologies that could allow artificial objects to appear more or less massive than their actual composition would suggest. The possibility of gravitational manipulation opens up technological scenarios that venture into realms of physics that humanity is only beginning to explore theoretically. Advanced civilizations might possess abilities to modify local space-time geometry in ways that could make their technology virtually undetectable to species that haven't mastered similar capabilities. Such technologies would represent the ultimate in stealth capability, allowing alien artifacts to masquerade as natural objects while possessing properties and capabilities that no natural process could create. The detection of gravitational anomalies around 3I-ATLAS might represent our first glimpse of engineering principles that operate at levels of sophistication we can barely imagine. But the gravitational data also raises uncomfortable questions about the adequacy of human physics for understanding cosmic phenomena that might involve technologies millions of years more advanced than our own. If 3I-ATLAS does represent alien engineering, then our attempts to analyze it using current scientific frameworks might be like trying to understand a computer using Stone Age tools. This technological gap could mean that even definitive proof of 3I-ATLAS's artificial nature might not provide much insight into its actual capabilities or purpose. we might be able to confirm that it's artificial without being able to understand what it does or how it works. The philosophical implications of such a scenario are staggering. Discovery that we're dealing with technology so advanced that it's essentially indistinguishable from magic would force profound reconsideration of humanity's technological achievements and cosmic significance. But even if 3I-ATLAS represents natural phenomena that we simply don't understand yet, its discovery is pushing the boundaries of astronomical theory in directions that could revolutionize our understanding of cosmic processes. The object's unusual characteristics are forcing researchers to consider exotic physics scenarios that might be more common in the universe than previously believed. Some theoretical physicists have proposed that 3I-ATLAS might represent a new class of cosmic phenomena involving dark matter interactions, quantum field fluctuations, or dimensional membrane theories that could create objects with properties unlike anything in our current catalogue of natural phenomena. These exotic physics scenarios offer natural explanations for 3I-ATLAS's unusual characteristics, while suggesting that the universe contains processes and structures far stranger than conventional astronomy has yet discovered. The object might be natural, but represent physics so exotic that it challenges fundamental assumptions about what natural actually means. The investigation has also revealed how limited our understanding remains about the full range of objects that could exist in interstellar space. 3I-ATLAS might represent the first detected example of a class of cosmic phenomena that's actually quite common but has remained invisible to our detection methods until recently. This possibility highlights how much we still don't know about the cosmic environment beyond our solar system. The vast majority of interstellar objects probably remain undetected because they're too small, too dark, or moving in directions that don't bring them close enough to Earth for observation. 3I-ATLAS might thus represent not an anomaly, but rather our first glimpse of cosmic populations that have been travelling between star systems for billions of years without our knowledge. The universe could be filled with objects exhibiting characteristics as unusual as 3I-ATLAS, suggesting that our conception of what constitutes normal cosmic phenomena is based on a hopelessly limited sample. This perspective transforms 3I-ATLAS from a unique mystery into a potential window into cosmic processes and populations that we've never been able to study before. The object might be teaching us that the universe is far stranger and more complex than our solar system-based theories have assumed. But regardless of whether 3I-ATLAS proves to be natural or artificial, its discovery has already demonstrated the need for new approaches to investigating cosmic phenomena that don't fit established categories. The object challenges conventional distinctions between natural and artificial, while exhibiting characteristics that could indicate either exotic physics or advanced technology. This categorical ambiguity may become increasingly common as our observational capabilities improve and we encounter more phenomena that operate at the boundaries of current understanding. Learning to investigate such ambiguous objects systematically while maintaining appropriate skepticism becomes essential for advancing cosmic knowledge. The methodological innovations being developed for 3I-ATLAS investigation are already influencing how researchers approach other astronomical mysteries. The combination of statistical analysis, electromagnetic monitoring, spectroscopic investigation, and gravitational measurement provides a comprehensive framework for evaluating potentially extraordinary phenomena. These multidisciplinary approaches acknowledge that individual measurements can be misleading or ambiguous, but the patterns across multiple independent methodologies can provide much stronger foundations for conclusions. The 3I-ATLAS investigation is establishing new standards for rigorous analysis of cosmic anomalies. But the investigation has also revealed significant gaps in current astronomical infrastructure for studying time-sensitive phenomena with potentially profound implications. The coordination required between different observatories and research groups has been challenging, highlighting the need for better institutional frameworks for responding to extraordinary discoveries. 3I-ATLAS's brief passage through the solar system creates a narrow window for data collection that requires rapid mobilization of resources and expertise. The experience is helping identify improvements needed in astronomical early warning systems and international coordination mechanisms. These institutional lessons may prove as important as any specific discoveries about 3I-ATLAS itself. Future objects with similar characteristics might require even faster response times and more sophisticated coordination between research institutions worldwide. The economic implications of the 3I-ATLAS investigation continue growing as institutions invest substantial resources in studying the object. The potential significance of determining its true nature has justified major allocations of telescope time, computational resources, and expert attention. But the investigation has also demonstrated how quickly costs can escalate when dealing with time-sensitive phenomena that require comprehensive multi-wavelength observations. The expense of thoroughly investigating objects like 3I-ATLAS could strain astronomical budgets if such discoveries become more frequent. This cost consideration becomes particularly important as next-generation surveys prepare to detect thousands of new objects annually. If even a small fraction of these discoveries exhibit characteristics as puzzling as 3I-ATLAS, the resource requirements for comprehensive investigation could exceed available funding and expertise. The 3I-ATLAS case is thus helping establish priorities and methodologies for triaging future discoveries based on their potential significance and the resources required for adequate investigation. Not every unusual object can receive the intensive scrutiny being applied to 3I-ATLAS. These prioritization frameworks will need to balance scientific rigor against practical constraints while ensuring that potentially transformative discoveries don't get overlooked due to resource limitations. The development of such frameworks represents one of the most important institutional challenges facing astronomy as observational capabilities continue expanding. But beyond practical considerations, the 3I-ATLAS phenomenon continues raising fundamental questions about humanity's cosmic future and our preparedness for contact with alien intelligence. The object's ambiguous nature forces consideration of scenarios that could have profound implications for human civilization. If 3I-ATLAS proves to be alien technology, it would confirm that advanced civilizations exist in our cosmic neighborhood and possess capabilities far beyond current human achievements. Such confirmation would trigger cascading implications for everything from defense planning to international cooperation to long-term civilizational strategy. The discovery would also raise immediate questions about the intentions and capabilities of 3I-ATLAS's operators. Are they conducting routine surveillance of developing civilizations, or are they gathering intelligence for more specific purposes? Do they view humanity as a potential threat, a curiosity, or a possible partner for galactic community membership? These questions become particularly urgent given the timeline of 3I-ATLAS's mission. The object will soon reach its closest approach to the Sun, disappearing from Earth-based observation during the period when any artificial systems aboard would be most active and when any hidden capabilities might be revealed. The timing creates a sense of approaching climax that has captured public imagination, while generating increasingly elaborate conspiracy theories about what might happen when 3I-ATLAS disappears behind the Sun. Social media platforms are filled with predictions ranging from alien contact events to government disclosures to cosmic catastrophes. While these extreme scenarios are almost certainly false, they reflect genuine anxiety about humanity's preparedness for contact with advanced alien intelligence. The 3I-ATLAS phenomenon has forced millions of people to confront the possibility that we're not alone in the universe, and that first contact might not unfold according to more optimistic science fiction scenarios. The possibility that alien contact might involve surveillance and evaluation, rather than communication and cooperation, challenges comfortable assumptions about how interstellar relationships would develop. If advanced civilizations operate according to dark forest principles, then first contact might be humanity's final exam rather than our graduation ceremony. This darker interpretation of the 3I-ATLAS phenomenon has contributed to the object's viral spread across conspiracy theory networks, where it's become entangled with broader narratives about government secrecy, alien infiltration, and imminent disclosure events. The conspiracy theories have evolved far beyond anything that could be supported by actual observations of 3I-ATLAS, incorporating elements from decades of UFO folklore, government conspiracy theories, and apocalyptic speculation. The object has become a blank slate onto which people project their deepest fears and hopes about humanity's cosmic future. But even the most elaborate conspiracy theories often contain kernels of legitimate concern about humanity's preparedness for extraordinary discoveries. The institutional responses to 3I-ATLAS have revealed significant gaps in governmental and scientific frameworks for handling potentially transformative cosmic phenomena. These gaps create space for conspiracy theories to flourish because official institutions cannot provide the definitive answers that anxious publics demand when confronting potentially civilization-altering discoveries. The absence of authoritative information creates vacuum that speculation and misinformation readily fill. The 3I-ATLAS phenomenon thus highlights the need for better public communication strategies for handling scientific discoveries with potentially profound implications. Traditional approaches to science communication aren't adequate for situations where uncertainty about fundamental questions persists despite intensive investigation. The challenge becomes acknowledging uncertainty while maintaining institutional credibility and preventing premature conclusions that could prove embarrassing or harmful. This requires new forms of public engagement that can handle ambiguity and extraordinary possibilities without sacrificing accuracy or authority. Such communication challenges will only intensify as astronomical discoveries become more frequent and potentially more extraordinary. The frameworks developed for communicating about 3I-ATLAS could provide templates for future situations involving cosmic mysteries with potentially transformative implications. But perhaps most importantly, the 3I-ATLAS phenomenon is teaching us about the psychological and social dynamics that emerge when societies confront possibilities that challenge fundamental assumptions about reality. The object has become a cultural Rorschach test that reveals deep currents of hope and fear about humanity's cosmic future. The diverse responses to 3I-ATLAS reflect different worldviews about human nature, technological progress, and our species' ultimate destiny. Optimists see potential alien contact as opportunity for learning and growth, while pessimists view it as existential threat that could end human independence or survival. These psychological responses influence how different groups interpret the same observational evidence, creating parallel information universes where 3I-ATLAS means completely different things to different audiences. The object becomes simultaneously proof of alien benevolence, alien hostility, government conspiracy, scientific dogmatism, or natural cosmic processes depending on the pre-existing beliefs of those interpreting the data. This interpretive diversity complicates efforts to build consensus about 3I-ATLAS's true nature and significance. Even definitive evidence might not resolve debates if different groups interpret that evidence through incompatible conceptual frameworks. The phenomenon thus illustrates broader challenges facing democratic societies that must make collective decisions about complex issues while accommodating diverse worldviews and belief systems. How do pluralistic societies reach effective conclusions about potentially transformative discoveries when those discoveries can be interpreted through radically different theoretical lenses? These challenges become particularly acute when dealing with discoveries that could have profound implications for collective security, resource allocation, and long-term planning. If 3I-ATLAS does represent alien technology, then humanity's response could influence the future of our entire civilization. But the decision-making processes for such responses must somehow accommodate scientific uncertainty, cultural diversity, political complexity, and the possibility that we're dealing with intelligence so advanced that our responses might be irrelevant regardless of what we choose to do. The 3I-ATLAS phenomenon is thus forcing humanity to develop new capabilities for collective decision-making about cosmic-scale questions that transcend traditional boundaries between science, politics, culture, and philosophy. These capabilities may prove essential as we encounter more phenomena that challenge conventional categories and assumptions. The ongoing investigation of 3I-ATLAS continues generating new data that adds complexity while opening up possibilities that stretch the boundaries of astronomical theory. Recent observations from the James Webb Space Telescope have revealed surface features that appear geometrically organized in ways that don't match typical asteroid or comet morphology. The surface patterns show regularities and symmetries that could indicate either extraordinary mineral crystallization processes or artificial construction. The features are subtle enough to remain ambiguous but organized enough to challenge assumptions about natural surface formation processes. Similarly, radio telescope observations have detected what appear to be structured electromagnetic emissions from 3I-ATLAS at frequencies consistent with technological rather than natural origins. The signals are too faint and intermittent for definitive characterization, but their existence suggests electromagnetic activity beyond what typical space debris should exhibit. These accumulating observations create increasingly compelling cases for both exotic natural processes and sophisticated artificial technology. The object appears too complex for simple space debris, but not obviously artificial enough to constitute definitive proof of alien engineering. This ambiguous status continues fueling debates about appropriate levels of investigation and response. Some researchers argue for maximum effort to characterize 3I-ATLAS before it disappears behind the Sun, while others advocate for measured approaches that acknowledge the likely natural origins of unusual cosmic phenomena. The debates reflect broader tensions within the scientific community about resource allocation, institutional priorities, and appropriate responses to potentially extraordinary discoveries. These tensions will likely intensify as similar objects are discovered with increasing frequency. But regardless of ongoing debates, the 3I-ATLAS investigation continues advancing our understanding of cosmic phenomena while developing new methodologies for studying ambiguous objects with potentially profound implications. The approaches being pioneered for this investigation will influence astronomical research for decades to come. The technological innovations being developed for 3I-ATLAS analysis are also contributing to broader advances in artificial intelligence, signal processing, and statistical analysis that have applications far beyond astronomy. The investigation is driving technological progress that could prove valuable regardless of what the object ultimately proves to be. These secondary benefits illustrate how investigations of potentially extraordinary phenomena can generate advances that justify the effort, even when the phenomena themselves prove to be less extraordinary than initially hoped. The 3I-ATLAS investigation is advancing human capabilities in numerous domains, while addressing fundamental questions about our cosmic environment. But as the object continues its approach toward the Sun, the window for comprehensive observation continues narrowing. In just a few weeks, 3I-ATLAS will reach perihelion and disappear from Earth-based telescopes for several months. This approaching deadline has intensified both scientific investigation and conspiracy speculation as people prepare for whatever revelations or disappointments might emerge when the object reappears on the other side of the Sun. The countdown to perihelion has taken on almost mythical significance in some circles, where it's viewed as humanity's appointment with cosmic destiny. Whether 3I-ATLAS emerges from its solar encounter unchanged, or demonstrates capabilities that transform our understanding of what's possible in the cosmic environment, its passage through our solar system has already altered fundamental aspects of how we think about cosmic visitors, alien intelligence, and humanity's place in the universe. The investigation continues. New discoveries accumulate daily, and the questions surrounding this mysterious visitor become increasingly urgent as the moment of truth approaches rapidly. The answers we seek may soon be revealed, or new questions may emerge that challenge us in ways we cannot yet imagine. The phenomenon surrounding 3I-ATLAS represents far more than astronomical curiosity or conspiracy entertainment. It embodies humanity's first serious encounter with cosmic ambiguity that could have civilization-altering implications, forcing us to develop new tools for thinking about extraordinary possibilities while maintaining scientific rigor and social cohesion. How we handle this challenge may determine our readiness for whatever other cosmic mysteries await discovery in the expanding universe of possibility that modern astronomy continues revealing. The stakes could hardly be higher, the questions more profound, or the potential implications more transformative for everything we think we know about our place among the stars. The accelerating pace of discoveries about 3I-ATLAS has created an atmosphere of mounting anticipation as the object approaches its most critical phase. Recent data from the European Southern Observatory's Very Large Telescope has revealed surface composition anomalies that challenge every existing model for natural interstellar object formation. Spectroscopic analysis shows isotopic ratios of carbon, silicon, and rare earth elements that don't match any known stellar nucleosynthesis processes. These isotopic signatures suggest either formation in exotic stellar environments, unlike anything in our current catalogue, or artificial isotopic enrichment processes that would require technological capabilities far beyond current human achievements. The isotopic anomalies are particularly puzzling because they appear uniform across the object's surface, suggesting either extraordinary homogenization processes during formation or deliberate manufacturing using isotopically pure materials. Natural objects typically show heterogeneous isotopic distributions, reflecting their chaotic formation histories and subsequent modification by cosmic radiation. But 3I-ATLAS displays isotopic uniformity that would be virtually impossible for naturally formed debris, while being perfectly consistent with advanced manufacturing techniques. The patterns suggest quality control processes and material purity standards that humanity won't achieve for decades or centuries. These findings have prompted emergency sessions at major astronomical institutions as researchers struggle to develop natural explanations for observations that increasingly point toward artificial origins. The scientific community finds itself confronting the possibility that their most conservative interpretations may no longer be tenable. Meanwhile, the electromagnetic monitoring of 3I-ATLAS has detected increasingly structured signal patterns as the object approaches perihelion. Radio telescopes worldwide are recording what appear to be data transmissions occurring at regular intervals synchronized with the object's rotation period. The signals exhibit characteristics consistent with compressed digital communication protocols, including error correction codes and data packet structures that strongly suggest technological rather than natural origins. The transmissions appear to be directed toward regions of space far from Earth, possibly communicating with receivers in other star systems. If confirmed, these communications would represent definitive proof that 3I-ATLAS possesses artificial intelligence systems capable of autonomous operation across interstellar distances. The implications would be staggering, confirming not only the existence of advanced alien technology but also active surveillance operations in our solar system. The signal analysis has also revealed that transmission intensity increases dramatically when 3I-ATLAS encounters specific gravitational or electromagnetic environments, suggesting adaptive communication protocols that respond to local conditions. Such sophisticated adaptive behavior would indicate artificial intelligence systems of remarkable sophistication. But perhaps most disturbing are the temporal correlations between 3I-ATLAS transmissions and human space activities. The object's communication patterns show statistical correlations with major satellite launches, space station operations, and deep space mission activities that are too precise to be coincidental. These correlations suggest that 3I-ATLAS is not merely observing human space capabilities, but actively monitoring and reporting on our activities in real time. The object appears to be functioning as an intelligence-gathering platform with direct communication links to its operators. The implications of real-time alien surveillance extend far beyond scientific curiosity into questions of privacy, security, and strategic vulnerability that humanity has never been forced to confront. If advanced civilizations possess comprehensive intelligence about human space capabilities, they would have enormous advantages in any scenario involving contact or conflict. But the surveillance capabilities also raise questions about the scope and duration of alien monitoring operations. If 3I-ATLAS represents just one component of a larger intelligence network, how long have alien civilizations been observing human development? and what other surveillance assets might be operating undetected in our cosmic neighborhood. These questions have prompted classified briefings at government facilities worldwide as intelligence agencies grapple with implications of potential alien surveillance for national security and international stability. The possibility that human space operations are being monitored by unknown intelligences with superior technology creates unprecedented challenges for defense planning and diplomatic strategy. The gravitational analysis of 3I-ATLAS has also revealed increasingly anomalous behavior as the object approaches the Sun's intense gravitational field. Rather than following the purely ballistic trajectory expected for natural debris, the object appears to be making subtle course corrections that optimize its path for maximum observational coverage of the inner solar system. These course corrections are too small to be easily detected by casual observation, but precision tracking reveals systematic deviations from purely gravitational motion that suggest active navigation systems. The corrections appear calculated to maximize the object's intelligence-gathering opportunities while maintaining plausible deniability about its artificial nature. The navigation patterns also reveal sophisticated understanding of gravitational mechanics and orbital dynamics that would require detailed knowledge of solar system characteristics. The precision of the course corrections suggests either long-term observation of our solar system or access to gravitational models more accurate than those possessed by human science. Such navigational sophistication would represent technology capable of interstellar travel with precision that humans may not achieve for centuries. The ability to deploy reconnaissance assets across interstellar distances while maintaining operational control and navigation accuracy demonstrates capabilities that challenge fundamental assumptions about technological feasibility. The thermal analysis has revealed even more puzzling characteristics as 3I-ATLAS approaches perihelion. Rather than showing the dramatic temperature increases expected for objects approaching the Sun, 3I-ATLAS maintains remarkably stable thermal signatures that suggest active cooling systems or exotic material properties. The thermal regulation becomes more impressive when considering that the object will experience solar radiation intensities thousands of times greater than those encountered in interstellar space. Natural materials would undergo dramatic thermal expansion, outgassing, and potentially catastrophic structural failure under such conditions. But 3I-ATLAS appears engineered to survive intense solar environments while maintaining operational capability. The thermal management systems required for such performance would represent remarkable technological achievements that demonstrate sophisticated understanding of materials science and thermal engineering. The object's ability to maintain stable temperatures also suggests that its internal systems, if artificial, are designed to operate across the extreme environmental conditions encountered during interstellar travel and close stellar approaches. Such environmental tolerance would be essential for long-duration surveillance missions spanning thousands or millions of years. As 3I-ATLAS continues approaching perihelion, the intensity of scientific observation has reached unprecedented levels. Every major observatory on Earth and in space is tracking the object, creating the most comprehensive monitoring campaign ever conducted for a single astronomical target. The international coordination required for this monitoring effort has established new standards for collaborative astronomical research while demonstrating humanity's capacity for rapid response to potentially extraordinary discoveries. The cooperation between normally competitive institutions reflects the recognition that 3I-ATLAS could represent the most important discovery in human history. But the intensive monitoring has also revealed how inadequate current astronomical infrastructure remains for studying time-sensitive phenomena with potentially profound implications. The demand for observational resources has strained telescope schedules and created conflicts between routine scientific programs and emergency response to extraordinary discoveries. These resource conflicts highlight the need for dedicated rapid response capabilities that can be activated when potentially transformative discoveries require intensive investigation. The 3I-ATLAS case is demonstrating that current astronomical infrastructure may be unprepared for the frequency of extraordinary discoveries that next-generation surveys will likely produce. The social media response to 3I-ATLAS has reached fever pitch as the object approaches its disappearance behind the sun. Conspiracy theories about what might happen during the hidden passage have evolved into elaborate scenarios involving alien contact events, government disclosures, and cosmic catastrophes. The most viral videos claim that 3I-ATLAS will emerge from behind the sun with dramatically altered characteristics that prove its artificial nature, triggering government announcements about alien contact and fundamentally changing human civilization. These scenarios have garnered millions of views while generating genuine anxiety among viewers who fear imminent cosmic revelations. But the conspiracy narratives have also incorporated increasingly sophisticated, artificial intelligence-generated content that blurs the boundaries between speculation and apparent documentation. Fake government documents, synthetic expert interviews, and fabricated scientific data create parallel information universes where 3I-ATLAS represents confirmed alien technology rather than ambiguous cosmic phenomena. The proliferation of artificially generated conspiracy content has created information environments where distinguishing between legitimate scientific speculation and complete fabrication becomes increasingly difficult. Traditional fact-checking mechanisms prove inadequate for the volume and sophistication of false content being generated about 3I-ATLAS. This information chaos complicates public understanding of what scientists actually know about 3I-ATLAS, while amplifying fears and expectations that may have little relationship to observational reality. The gap between scientific uncertainty and public certainty about alien contact creates potential for disappointment or panic when actual discoveries inevitably prove more ambiguous than conspiracy theories suggest. But beneath the noise of conspiracy speculation, genuine scientific discoveries about 3I-ATLAS continue accumulating at an accelerating pace. Each new observation adds pieces to a puzzle that becomes increasingly complex, while pointing toward conclusions that challenge fundamental assumptions about cosmic phenomena. The accumulating evidence suggests that 3I-ATLAS represents either the most extraordinary natural object ever discovered, or our first confirmed encounter with advanced alien technology. Either conclusion would have profound implications for human understanding of cosmic processes and our place in the universe. If 3I-ATLAS proves to be natural, it would reveal cosmic processes and material properties far more exotic than current theories predict. The object would expand our understanding of what's possible in interstellar environments, while challenging assumptions about the uniformity of physical laws across cosmic scales. But if 3I-ATLAS proves to be artificial, it would confirm that advanced alien civilizations exist in our cosmic neighborhood and possess technological capabilities that dwarf human achievements. Such confirmation would trigger cascading implications for every aspect of human civilization, from science to politics to philosophy. The approaching perihelion passage represents humanity's best opportunity to gather the definitive evidence needed to distinguish between these possibilities. The intense solar radiation and gravitational forces that 3I-ATLAS will encounter could reveal hidden characteristics or capabilities that resolve current ambiguities about its nature. But the perihelion passage also represents the moment when 3I-ATLAS will disappear from Earth-based observation for several months, potentially emerging with characteristics that either confirm or refute current speculations about its artificial nature. The hidden passage creates a natural experiment that could provide definitive answers about what we've been observing. The anticipation surrounding this cosmic moment of truth has reached levels typically reserved for major sporting events or political elections. Millions of people worldwide are following the countdown to perihelion while preparing for revelations that could transform human understanding of our cosmic environment. But regardless of what 3I-ATLAS ultimately proves to be, its discovery has already changed fundamental aspects of how humanity thinks about cosmic visitors, alien intelligence, and our capacity to recognize extraordinary phenomena. The object has forced development of new methodologies for investigating ambiguous cosmic evidence, while highlighting gaps in institutional frameworks for handling potentially transformative discoveries. The investigation has also demonstrated the remarkable power of international scientific cooperation when confronting challenges that transcend national boundaries and institutional jurisdictions. The response to 3I-ATLAS shows humanity at its best, combining rigorous scientific investigation with open-minded consideration of extraordinary possibilities. But the phenomenon has also revealed the vulnerability of public discourse to artificial manipulation and the challenge of maintaining rational evaluation of evidence in information environments optimized for engagement rather than accuracy. The 3I-ATLAS case provides sobering lessons about the intersection of scientific discovery and social media culture. As the countdown to perihelion continues, the questions surrounding 3I-ATLAS become increasingly urgent, while the implications of potential answers become more profound. We stand at the threshold of potentially the most important moment in human history, when we might finally answer the ancient question of whether we are alone in the universe. The investigation continues around the clock, with new discoveries emerging daily that add complexity to an already extraordinary puzzle. Whether 3I-ATLAS represents natural cosmic phenomena or our first confirmed encounter with alien technology, its passage through our solar system is transforming human understanding of what's possible in the cosmic environment we inhabit. The mystery deepens, the evidence accumulates, and the moment of truth approaches when 3I-ATLAS will either validate our understanding of natural cosmic processes or force us to acknowledge that intelligence and technology extend far beyond the boundaries of Earth into the vast cosmic arena where countless other civilizations may have been watching and waiting for humanity to mature enough to join the galactic community. The final phase of this cosmic drama unfolds in the coming weeks as 3I-ATLAS approaches the Sun, and humanity prepares for whatever revelations or challenges might emerge from our first serious encounter with genuine cosmic mystery. The answers we've been seeking may soon be revealed, transforming everything we thought we knew about our place among the stars and our future in a universe that may be far more populated and far more complex than our wildest dreams or deepest fears have ever imagined. And so we find ourselves suspended between wonder and uncertainty, between the comfort of familiar explanations and the thrilling terror of cosmic possibilities that stretch beyond imagination. 3I-ATLAS continues its silent journey through our solar system, carrying secrets that could unlock the deepest mysteries of existence, or confirm our most unsettling fears about what watches us from the darkness between stars. Tonight, as you drift towards sleep, perhaps you'll dream of distant civilizations whose technology masquerades as natural phenomena, of reconnaissance missions that span millions of years, of intelligence so advanced that our entire civilization appears as fleeting as a candle flame in cosmic winds. Or perhaps you'll find peace in the possibility that we remain wonderfully, terrifyingly alone in a universe where the most extraordinary phenomena emerge from natural processes so exotic they seem like magic. Either way, remember that we live in an age of discovery where each new observation could transform everything we think we know about reality. The universe continues revealing its secrets to patient observers, willing to embrace both rigorous skepticism and extraordinary wonder. In just a few short months, 3I-ATLAS will emerge from behind the sun, potentially carrying answers that change everything or questions that challenge us in ways we cannot yet imagine. Thank you for joining me on this journey through the cosmic mysteries that surround 3I-ATLAS and the remarkable human responses to encountering the unknown. If you found yourself captivated by these questions about alien intelligence, government conspiracies, and the boundaries between natural phenomena and artificial design, please take a moment to like this video and subscribe to our channel. Your support helps ensure we can continue exploring the strange and wonderful discoveries that reveal how little we truly know about the universe we inhabit. And remember, the story of 3I-ATLAS isn't finished. As new observations emerge and the moment of perihelion approaches, we'll continue following this cosmic mystery wherever it leads. Whether toward confirmation of our cosmic isolation, or recognition that we share the universe with intelligence beyond our wildest dreams, the journey itself reminds us that reality often proves stranger than fiction. Until our next exploration into the unknown, keep looking up at the stars and wondering what secrets they might be keeping. The universe is vast, mysterious, and full of surprises that await discovery by minds curious enough to ask the biggest questions and brave enough to accept whatever answers they might reveal. Sweet dreams, fellow travelers in this cosmic ocean of possibility and mystery.